Hello guys, welcome to Unacademy NEET English YouTube channel. I'm Kailash Sharma and today I'm going to teach you a very important topic, or you say first topic of the physics, and that is the rectilinear motion. It's the part of the kinematics. So kinematics can be divided into three parts: a rectilinear motion, projectile motion and the relative motion. So first part, that is the rectilinear motion, or sometimes we call it motion in one dimension, we are going to cover in next 3-4 hours in today's session. So I have there is a slight change in the pattern, the way I teach you on this channel. Today I did not have the written notes. I'll write each and everything in front of you, and then you can prepare the notes along with me. So basically guys, this is going to be super fun and I hope you all are excited for that. So rectilinear motion is the first topic of the physics. Many of you were not able to join the previous classes because I was teaching the last topic, that was the thermal physics, and because of that I got so many messages as well. Sir, please start from the starting topics, so that in a flow we are able to complete the complete class 11th. So that I am going to do from now onwards. I will be teaching you the topics in a sequence, which is a class 11 sequence. So we start the class. Before I start the class, do not forget to like this session. Please like this session, share among your community, among your friend circle, so that more and more number of students can join this session. And don't forget to subscribe this YouTube channel where your favorite educators of the Unacademy, they are the top educator as well, are teaching you in this series. And it's day 31. And day 31, I'm taking my 5th or 6th class, and they all are working very hard, with a dedication, and they all complete this series with this same entho. Like this series will be very beneficial for all the aspirant preparing for the NEET 2024, and I'm happy that I'm the part of this team, and there is my contribution as well in your NEET preparation. And all the time I try, like, what is best for you, I try to provide that. So this is, so whatever can be done from my side, that I'll definitely do. You can connect with me, or you can comment after the session. If there's anything you want to share with me, you have to just leave a comment. I go through your comments, I check if there is anything more that can be done. Like in the previous session, I did not teach the calorimetry part. So one student mentioned that, sir, please complete that in the comment section, and I'll definitely complete it. If you want it, I'll do it. So this way we will complete this series. So 31, this is the 31st lecture of this marathon series. So today we are going to start the motion in one dimension, or we call it rectilinear motion. So guys, let's start the session. Before that, I want to share a information with you. There is a batch going on the Unacademy, that is a crash course, and that NEET end game crash course. And in that crash course, I am teaching the 11th part. So you can join that batch. And to join that batch, you can use this referral code, that is the Kailash 10. This is my referral code. Use this referral code and enroll in that batch. And you can start preparing for the NEET 2024 under the guidance of the top educators of the Unacademy. Voice is breaking. Let me check once. Wait. Hello. Give me 1 minute. Let me check it. Referral code. Use this referral code and enroll in that batch. No, guys, there is no such problem. Like, everything is fine. There is no such problem. I cannot find any such problems. It's fine. It's all good. No problem on my side. What happened to this? Okay. So guys, let's start the session. Everything is fine, yes. Okay. So we are going to start the session, motion in one dimension. And so first we will talk about what is this motion. We are going to study it in this lecture. motion. So let's understand motion. And then there is a word that is called the kinematics. I told you in start of this session that rectilinear motion is the part of the kinematics. So what we study in kinematics, all these things we will go through first, and then we will enter into the topic. Okay. So there is this word. What is the meaning of these two words, motion and the kinematics? I'm going to tell you first the meaning of these two words. So guys, let's say a particle is there and it is in motion. Okay. So particle is doing motion. So let's say it is moving in XY plane. So there is a plane which is the XY plane. You also can draw all these things. You can draw these things along with me, like you will get enough time to do this. I don't know why this is not sticking with it. Okay, it's fine. So let's say a particle is moving in XY plane. So there is this plane, XY plane, and a particle is moving in it. So x-axis is there, y-axis is there. A particle is situated at this point. Okay. When I start studying the motion, particle was at this point. This is called its initial position. Okay. This is called the initial position. See, position and motion are always talked with respect to some observer. So this is our origin, and you can call it, this is our observer. So it is observing the motion of this particle. You are asking this observer, where is the particle? So when you ask, where is the particle? It will point in this direction. It will say, there is this particle. Okay. It will point in this direction and say, position of the particle is this. So it will say, this observer will say, particle is at that point. So this is called the position vector. What do we call this vector? This is called the position vector, and because it is representing the initial position, so this is called the initial position vector. Okay. So there is a very important term in this topic, and that is called the position vector. That is called the position vector. So there is a position vector. We have to define first position vector. So there will be some observer and it will define the position of the particle. So like this is our observer and it is saying the particle is at that point, and this is called the position vector. This R vector is called the position vector. Position vector is written like this. It is written like in terms of x coordinate, y coordinate and the z coordinates. So we represent position vector with R vector, with R, and we write it like this: xi cap, yj cap, plus ka z, k cap. This is called the position vector of the particle. So position vector of the particle depends on what things? Like what the coordinates of the particle. So wherever is the particle, its coordinate, with the help of the coordinate you can define the position vector of the particle. So there will be some coordinate of the particle, x1, x, y, z. So we are saying the particle is moving in the xy plane, so z coordinate will be 0. Okay. So position will come in terms of x and y only. Got it? No problem. Any problem till now? No. So particle is at this point and its position vector is defined like this. Now particle is moving. So when particle move, its position vector changes. So let's say particle is moving like this. This is the path of the particle, and particle reaches this point. So this is the path of the particle. Particle started from this position and reaches this position. So this is called the final position. Okay, this is called the final position. This is the final position. So we define vector for it as well. So final position vector will be like this. So this is the final position vector. This is the final position vector. This will be the final position vector. So path of the particle is this. So particle moved through this part. So this is called the path of particle. So path of particle, you can see particle started from this position, reached to this position. So this position vector is changing. Like whenever particle is in motion, the position vector will change with time. So there is the definition of the motion. I told you, like first we will define what is the motion. So I am going to define the motion first. So what is the definition of the motion? So what is motion? The word you already are very familiar with this word. There is a definition for this word as well, motion. So whenever position of the particle, when position of the particle when position of particle changes with time, when position of the particle changes with time, position vector changes with time, then particle with time, then particle is said to be in, now you will be able to define the motion as well. Particle is said to be in motion. So if position vector of the particle is changing with time, then particle is said to be in motion. So the position vector of the particle must change with time, then and only then you say that particle is in motion. Okay, so particle will be in motion when its position vector is changing with time. See, position vector is x I cap, y j cap and the z k cap. So out of x, y and z, anyone could change. Like there is no constant that all have to change. No, either x will be changing with the time, either y will be changing with the time, either z will be changing with time. Then the particle will be said to be in motion, because the position vector is ultimately changing with time. So for a particle to be in motion, its position vector must change with time. So let's say if a particle is moving along the x-axis only, parallel to x-axis, then its only x coordinate will change. If a particle is moving along y-axis, parallel to y-axis, only y coordinate will change. Only y coordinate will change. If a particle is coming out, only coming out, it is not going in this direction, not going in this direction, only coming out of the plane of the paper, then only z coordinate will be changing. So if any of these three is changing, then particle is said to be in motion. So position vector is defined with respect to an observer, and if any out of these three parameters, which are x coordinate, y coordinate or z coordinate of the particle, are changing with respect to time, then particle is said to be in motion. Is this clear? How do we define the motion of the particle? So any of these three could change. So if particle is performing rectilinear motion, x coordinate, only x coordinate will be changing. If particle is going along the x-axis, if particle is going along the y-axis, only y coordinate will be changing. Okay, like particle is doing this type of motion, x and y both will be changing. So this is called the motion in a plane. So only x coordinate and y coordinate are changing. Z coordinate is not changing. What if particle start from here? It come out of the plane, then went into the plane and move like this. Then all three will be changing with the time. X, y and z, all three will be changing, and that is called the motion in space or motion in 3 dimension. So mainly in kinematics we talk about the motion along a straight line and motion in a plane. Okay, so these two type of motion we are going to study. So what is the motion? Definition of the motion: if position vector, and position vector is always defined with respect to some observer, we are taking that observer as the origin. So this is our observer, and it is saying, see, initially particle was there, so it was pointing like, okay, particle is there. Now particle started moving, so it has to change the direction. So let's say particle is at this point. Now position vector will be what? When particle is at this point, somewhere here, so the position vector will be like this. This is a position vector at any time. Okay, so this is a general position vector at any time. Like see, particle is here, particle is there, position vector direction will change, magnitude will change. So particle is moving, then its position vector will definitely change. Okay, got it? Is this clear? Is this clear? So position of the particle changes with time, then particle is said to be in motion, and position vector is defined like this. So there is a so I have defined, so ultimately motion is related to the position vector. It should change for the motion, and it is defined with respect to some observer. So motion will also be with respect to some observer. Okay, motion will also be with respect to some observer. Now we have already studied this point, which is the motion. There is a very important point, and that is the kinematics. What we study in the kinematics? What is the meaning of the kinematics? What we do in kinematics? So kinematics, let's understand this as well. What we do in kinematics? What is the meaning of the kinematics? So basically we talk about the motion, which we already know. What is motion? We study motion without without going into cause of the motion, without going into causes. Cause क्या होते हैं? What are the causes of the motion? Force and torque. Causes of the motion. So what force is causing this motion? We are not interested in it. How much force we have to apply for this motion? We are not talking about that. Well, we are just saying, okay, particle is given some velocity here, particle is given some acceleration, and it is moving. Who is providing that acceleration? We are not worried about that. What force is responsible for that acceleration? What torque is responsible for any angular acceleration? We don't talk about them in kinematics. We don't talk about the force. We don't talk about the torque in kinematics. We just study the motion. There are some parameters of the motion. We just talk about them without going into the cause of those parameters or cause of the motion. So if a particle is some particle is moving, then we don't talk about what are the forces responsible for that motion, and that study we do under kinematics. There is a one more like kinematics. There is another term is that is called the dynamics. Dynamics is in dynamics we talk about the causes of the motion, like force and the torque. So after kinematics, once we complete rectilinear motion, projectile motion, and the relative motion, we study Newton's laws of motion. That is the part of the dynamics where we talk about how much force is required for particular acceleration or velocity is changing with acceleration, and what are the forces responsible for that. In rotational motion, we talk about the torque, and those are the part of the dynamics. So kinematics and the dynamics. So this way we divide a motion in these two categories, kinematics and the dynamics. So when we are talking about the motion of a particle, we divide, we have two categories. The one is the kinematics and another is the dynamics. So we are talking about, right now we are talking about the only kinematics. So in kinematics, there are some parameters of the motion, very important parameters of the motion. We are first going to talk about them. So there are certain parameters of the motion. So there is motion, and to understand motion, we need to define some parameters. So parameters of motion. So there are certain parameters of the motion. So one parameter we have already studied, that was the position vector. One parameter we have already studied, that was the position vector. There are other parameters of the motion. First parameter is called the, whenever particle is moving, it will cover some distance. The particle will cover some distance, travel. So distance is the first parameter. Distance, and along with that there will be displacement. So distance and displacement, we will talk about them first. So distance and displacement, we will talk about them. Next one is the velocity. So velocity and speed, there are these two parameters as well. We will talk about the average velocity and average speed as well. And the third parameter is acceleration. So we are going to understand all these parameters first. Okay, we are going to understand one by one them, and then we will talk about the motion with uniform acceleration, and then motion under gravity of the earth, graph related problem. This topic is done. So this is the overview of the topic. We will talk about all these parameters. We will understand them, each one of them. We will solve some numerical on them. Then we will move to, when we clearly understand them, then we will move to the motion under uniform acceleration, motion under gravity of the earth, and then some graph related problem, and topic is over. Okay, so this is the flow of this class or overview of the class, like the way we will be talking about the topics. So clear till now? Any problem? Any problem till now? Okay, got it. So let's talk about one by one. We will talk about the distance and displacement. So whenever particle is in motion, it will cover some distance, and there we will define displacement. So what is distance, what is displacement? Let's talk about them on the next page. So here I am going to write both on the same page. So distance and displacement. So here I'll write all the things about the displacement, and here I'll write all the things about the distance, and here I need to draw that path of the particle, so that we don't have to go to the back page every time. I think you all are able to note down the things. There is no such problem in like writing down these things. Okay, so this is x-axis, this is y-axis. So particle was initially at this point, it is moving like this and reaches this point. So this is the path of the particle. Got it? The path of the particle is given, initial position and the final position are given. So initial position is this is the initial position vector, this is the final position. Okay, this one is initial position, and this one is final position. Okay, final position, initial position. We have already talked about them now. This is initial position vector, this is the final position vector, and this is the path of the particle. It is started from here and ends here. So the duration of the motion which we are talking, this is the path of the particle. Here I am going to write all the things about displacement. So displacement, what is displacement? And here I'll write all the things about the distance. These are two very important parameters. Most of the time distance creates a problem. Like most of the time students are confused or are not able to find the distance. Distance is very confusing actually. Now, if somebody asks a question on distance, there are highly chances that you will not be able to answer it correctly. Distance is really confusing term. I'll talk about that. You'll say, sir, these are very easy topics. Like we are taking so much time in these, but later on you'll come to know that these are the most tricky concepts. They both are the most tricky topics. So okay, so displacement. It is a vector. It is a vector joining. It is a vector joining final position. It is a vector joining final position from initial position. So displacement is a vector. Okay. It is a vector joining final position from the initial position, or you have learned the definition. Shortest distance between the initial and the final position is called the displacement. But that is the definition when you have not studied the vectors. Now you have already studied the vector, so it is a vector which join the final position from the initial position. So a vector which start from the initial position and join the final position is called the displacement vector. So you stand here, you just draw this line. Let's change the color of this. So this line, you start a vector from the initial position and join the final position of the particle. That is called the displacement vector. So S vector is called the displacement vector. Can you understand this? S vector, which is the displacement vector. So we represent displacement with S vector. So whenever you have to find the displacement, you just draw the line from the initial position to the final position, or draw a vector from the initial position to the final position, and you get the displacement vector. So displacement vector is clear to everyone. What is distance? The length of path, the length of the path traveled, the length of the path traveled by the particle. The length of the path traveled by the particle is called distance. So can you see the path of the particle? All you can see the path of the particle. This is the path of the particle. So the distance will be the length of this path is the distance. It is a scalar physical quantity. So distance is basically scalar physical quantity. Okay, it is scalar physical quantity. Distance is scalar. Okay, distance can never decrease. There is a very important term. Distance can never decrease. Distance can never decrease. Distance can never decrease. This is very important point. Distance will never decrease. It will never decrease. It will be either constant or it will always be increasing. So if somebody says like I have drawn a distance versus time curve. Somebody says like this is a distance versus time curve. So is it correct or wrong? Like somebody asks whether this is correct or incorrect. So let's say they say कि distance versus time. So this is distance for a particle. So somebody draw this curve, distance versus time curve. So it will never be decreasing. Like it can be constant but always be increasing. It should never go down. Here it is constant. So with time the distance is not increasing. So the particle is at rest. It should always be increasing. Okay. Sometimes they might ask or confuse you about this kind of curve. So distance curve should never come down. It will never come down. Okay. Got it? You got the idea? It should never come down. Like here also I must redraw it. So this cannot be the distance curve. This can never be the distance curve. Distance can never decrease. So it might be constant or increasing. So I said it can never decrease. I did not say it cannot be constant. If I said distance is always increasing, this is also wrong statement. Distance can be constant as well. So constant is not called the increasing. Okay. If you say the value of this thing is constant, so you cannot say it is always increasing. Okay. But if something can be constant or increasing, then you say it will never be decreasing. Got it? The magnitude of displacement, because vector is a displacement is a vector. So magnitude of displacement can never be greater than this magnitude of displacement can never be greater than this distance. So magnitude, so I am saying, see, if you are comparing a vector with a scalar, you just compare the magnitude. You can never compare a vector with a scalar. Like vector cannot be compared with a scalar. Its magnitude can be compared. So when you say magnitude of the displacement can never be greater than the distance, so it will always be less than or equal to distance. So magnitude of the displacement will always less than or equal to the distance. They both are equal. Distance and magnitude of displacement. So we write in mod. The distance and displacement both are equal. Both are equal. If they both are equal, when they both are equal, distance and displacement both are equal. When they both are equal, distance and displacement, when the distance is equal to displacement, when they both are equal. When are they equal? When are they equal? So most of you say, sir, when they are traveling a straight line. No, distance and displacement both are equal if particle moves without changing its direction. Particle moves without changing its direction. Direction must not change. Changing its direction. So particle must not change the direction of motion. Its velocity should not change its sign. Then and only then distance and displacement are equal. So distance is equal to magnitude of the displacement if particle moves without changing its direction. So if particle moves without changing its direction, then distance and displacement both are equal. Got it? So I'll explain that. Like why did I deny that the particle is traveling in a straight line, and that in that case we don't say that distance and displacement both are equal. So all the points on this page are clear to each and every one. So we can move to the next point. Okay. Now we are still talking about the distance and the displacement. So let's say a particle is moving here. Let's say a particle is moving like this. So particle starts its motion from here to here. Okay. And in the same line it came back this much distance. Okay. What is happening in the same line? But I want to represent both the motions separately. That's why the particle went like this and came return like this. So this is the final position. This is final position. Okay, and this was the initial position. Is this motion initial position? So is this motion a motion along a straight line? Is this an example of the motion along a straight line? Like I threw this marker. Is this an example of the motion along a straight line? If I consider this as a particle, point mass, this goes up and comes down. This is moving in a line only. This is also an example of the straight line. Yes, this is motion along a straight line. You say, sir, it is not coming. See, I have just draw it like that so that you can differentiate this motion and this motion. That's why I have just shifted it a little bit. But they both are in a line. This is a motion in a straight line. Okay. So let's say this distance is this distance. This is L2 and this distance is L1. This distance is L1. So one is L2, this distance is L2 and this distance is L1. So what is distance here and what is the displacement? What is distance? So what is the distance traveled by the particle? Distance. What is the magnitude of the displacement? What is the magnitude of the displacement? Can you tell me both distance and the displacement? Can you tell me both? What is the distance here? What is the displacement here? What is distance and what is displacement in this case? What is distance and what is the displacement in this case? Distance and displacement. So, see, to find the distance, you have to check the complete path. You'll say, sir, it is moving in this direction, L1 distance. Now it is coming back, L2. Distance can never decrease. So L1 plus L2 are the distance. So L1 plus L2 is the distance. Okay. Now you say, sir, displacement. I'll tell you, sir. Displacement is very easy. How do we find the displacement? What is the procedure to find the displacement? So when you are finding the displacement, you just start a vector from the initial position and join the final position. So displacement vector is a vector joining final position from the initial position. So white line is the displacement vector. Is this clear? Displacement vector does not have anything to do with the path of the particle. Whatever path is traveled by the particle, displacement vector has nothing to do with the path of the particle. It just simply says, just tell me the final position. I'll draw a vector from the initial position. Start a vector from the initial position pointing to the final position, and that is called the displacement vector. Is the definition of the displacement vector clear to each one of you? So displacement vector will be this vector. So it is equal to L1 minus ka L2. This is the displacement vector. So are they both equal? No, it is a rectilinear motion, but distance is not equal to displacement. So when I ask you, when distance is equal to displacement, you just said, sir, motion in a straight line. This is also motion in a straight line, but they both are not equal. See, there is a one important point. Particle should not change its direction. If particle is not changing its direction, then distance is always equal to displacement. Then you'll say, sir, but you did not say it should move in this rectilinear, it should move in a straight line. See, when I said na, particle must not change its direction, that implies particle is moving in a straight line only. See, somebody is going like in this direction and it is not changing its direction, then it will move in a straight line. Obviously, you don't have to define. When you have written this na, like distance and the magnitude of the displacement both are equal if the particle moves without changing its direction of the velocity. Without changing its direction of the velocity, that implies that particle is moving in a straight line. You don't have to say again, you don't have to say that particle have to travel in a straight line. No, this definition already include that part. Got it? So this was the first case where you can understand that you have to track the path of the particle while talking about the distance and the distance, and only initial and final position when talking about the displacement. So let's talk about one more example. Okay, this was the first example. I could not write it here. So this is first example of the example 1 on distance and displacement 1. One more illustration. Okay, there are 3 very important cases. If you understand all those 3, you understand distance and displacement. Example. So whenever somebody asks you, I ask my student to be very cautious whenever you are finding the distance. When somebody asks you a question of distance, it is very difficult to answer, like difficult to answer. Always bells should ring in your mind, like sir, there could be a trap as well. Like distance, finding a distance is very tricky task, because you have to track the path of the particle. You have to make sure particle is not changing its direction, and only then distance and displacement both are equal. So example number 2 is when you throw a particle. Okay, this is also very very good example actually. Yeah? So you are throwing a particle from here. You are throwing a particle from here. You said, sir, this particle is thrown. This particle is thrown upward. Okay, it is thrown upward. Now you said, sir, it went up. How much? It went like this. Okay, this is the final position of the particle. Got it? Now it is coming downward. It came here. This is the final position. Let's say we are talking till here. Final position. So this is the final position. Particle went up, then came down. Is there any confusion, like, sir, why are you drawing this line? Why shifting on the right side? Just to clearly you are able to understand that they both are the upward motion and downward motion can be differentiated. That's why I have just shifted that line. Okay, let's say particle is moving 80 or 20 meter upward. It is moving 20 meter upward and 5 meter downward. Okay, so it goes 20 meter up and came down 5 meter. Okay, so these are the 2 positions, and initial and final position are given to you. This is the initial position. The particle was projected from here, and particle is coming down like this. Okay, can you tell me the distance and displacement in this case? What is the distance traveled by the particle? Distance and displacement. Can you tell me both? What is the distance and displacement in this case? What is the distance and displacement in this case? Can anyone tell me the distance and the displacement in this case? Can anyone tell me the distance and the displacement in this case? Distance and displacement in this case. What are the distance and the displacement in this case? Can you tell me? See, when nothing is given, the upward direction is taken as a positive and the downward direction is taken as a negative. So there is a very important point. There is a sign convention. I forgot to write that there. So sign convention is there. What is sign convention here? In rectilinear motion, we just take one direction as positive, one direction as positive, and other direction as negative. Other direction as negative. So in case of rectilinear motion, you don't have to write I cap or j cap. To represent the direction, you just take one direction as the positive and other direction as the negative, and simply write all the motion parameters. So this is the sign convention used. So if nothing is given, generally upward direction is taken as positive, downward as negative. If somebody says particle is moving along the x-axis, then x-axis is the positive direction and negative direction along the x and positive x and along the negative x. So can you tell me the distance and displacement in this case? What is the distance? So you are saying, sir, distance is, what is the distance? So it went up 20 meter, came down 5 meters. So distance is 20 plus ka 5. And this comes out to be 25 meter. Distance clear to everyone? It was very easy. And I can see the answers of the displacement. So few answers are like plus 15, few are minus 15. So what will be the displacement? What will be the displacement in this case? So you know, again, you don't have to worry about the path taken by the particle. What you have to do? You have to simply draw a vector from the initial position and joining the final position. So what is the initial position? It started motion from here. What is the final position? This. It went up, down, on only upward or only downward. It hardly matters. You have to draw a vector starting from the initial position, joining the final position. This vector is called the displacement vector. This vector is called the displacement vector. So what is the direction of the displacement vector here? It is upward. Direction of the displacement vector. What will be the displacement? The magnitude of the displacement? 20 minus ka 5. So 15 meter, and it will be positive and it will be upward. Okay. So the direction of the displacement will be upward and it will be 15 meter. Got it? This was the example 2 on the displacement. Let's talk about the example 3. Example 3 to understand distance and the displacement. These are very, very important examples. Now, most of the confusion are just because of them. If you have solved any good material, then you will understand how much pain they have caused to you. So example 3. Okay. These are the basics. Like before starting the rectilinear motion or motion with uniform acceleration, we have to understand what is distance, what is displacement. These all things must be clear to each and everyone. So let's say there is a building, there is a tall building, and the height of the building is 20 meter. Okay. Height of the building is 20 meter. You go like this. Height of the building is 20 meter. Okay, this is the ground, and somebody has projected a particle from here. Somebody has projected a particle from this point. Particle is projected from this point. It is projected like this. It went up. Particle went up and came down here. Okay. It went up and came down. The distance traveled upward is this distance, which particle has traveled in upward direction is given as, let's say, 7 meter, yeah, 8 meter. It went up 8 meter and then came downward like here. So this is the final position, na? Final position. Let's say you started motion, the particle started motion from here, reaching this point, and this is the initial position. This is the initial position, and the final position. So can you write or can you tell me the distance traveled by the particle? Okay, so can you write or tell me the distance and the displacement of the particle? Displacement with sign. So you are taking upward direction as a positive. Any vector in upward direction will be positive. Any vector in the downward direction will be taken as negative. Okay, so just tell me both of them. Can you tell me both of them? What is distance? What is this? Oh no. Oh no. What is distance? What is displacement here? In this case, if you are able to answer all these three, you are pro in finding distance and displacement. Distance and displacement. Distance and displacement. What are the distance and displacement in these two cases? So distance is the path of the particle. It went up 8 meter, then came down 8 meter, then 20 meter. So what is 8 plus 8 plus? Distance is 8 plus 8 plus 8 plus 8 plus 20. So it will be 36 meter. 8 plus 8 is 16 plus ka 20. It will be 36 meter. The distance is 36 meter. Yes. What is the displacement? Displacement. What is the displacement here? What is the displacement in this case? Displacement in this case. Guys, don't forget to like the session. I'm doing a lot of hard work for all of you. So please like this session before we go ahead, na? And share also among your friends. So how do we define the displacement? Displacement is defined like this. Displacement is what? A vector joining the final position from the initial position. So where is the initial position? Here. Where is the final position? Here. So this is the displacement vector. This is the displacement vector. Displacement vector. After attending this class, you must be able to solve each and every material available on NEET and this topic, in NEET. You must be able to solve all the materials like of any coaching institute. That level of teaching you'll see in next 3-4 hours. Like you will not find a difficulty when you go to solve any material of any coaching. And that is my commitment to you. Like you will not find that difficulty. You can come later and tell me, sir, I solved this material and I am able to solve at least 80-90% question of that material just by watching this session. So this session is going to be that in that detail. I am there, I am standing here, and I assure you this will definitely happen. Just go and solve any material, any available material in the market. You will not find it difficulty while solving that material because I teach in that detail only. So displacement vector will be here minus ka 20 meter. Displacement vector will be minus ka 20 meter because it is in downward direction. So now displacement you write minus 20 meter. Now displacement you write minus ka 20 meter. Clear? All these three examples are clear to each and everyone about the distance and the displacement. So these are the one of the most beautiful examples on the distance and the displacement. So this is an extra page which we don't require now because I have already covered the all those. Yes, I can cover this one also. Like I can teach you something on this page as well. So guys, there are sometimes particle is moving along a straight lines, but it is in parts. It is changing its direction. Like for the first 5 seconds, suppose it is moving in a straight line in north direction, then it changes its direction towards the east or some other directions. So how do we solve the questions of that kind? So let's say a particle is moving along the straight lines but in multiple directions. So this is a plane. In that plane the particle is moving. So this is, let's say, this x-axis, this is the y-axis. So the motion of the particle is first along the x-axis, okay, then it is started along this direction, then it started along this direction. So this is the S1 vector, initial displacement, S2 vector, S3 vector. So we have to find the net displacement of the particle. So what is the initial position? This is the initial position, okay? Initial position. Okay. What is the final position? This is the final position. Final position. What we have to do? How do we find the displacement vector? So displacement vector is nothing but a vector joining initial position to the final position. A vector starting from initial position and joining the final position is called the displacement vector. This is the S vector. Okay. Net displacement vector will be this. So net displacement is given by resultant of the displacements. So it is a vector resultant of displacement. S1 vector in terms of I cap, j cap and k cap. You write these vectors in terms of I cap, j cap and k cap. S2 vector in terms of x2 I cap, y2 j cap and z2 k cap, component of the vector. And similarly S3 vector. So the net displacement will be equal to, what will be the net displacement? The net displacement vector will be equal to x1 plus x2 and so on I cap, y1 plus y2 and so on j cap, z1 plus z2 and so on k cap. This is the net displacement vector. This way we find the net displacement vector. This is the way we find the net displacement vector if more than one displacement vectors are given. So resultant of multiple displacement vector can be found out with this formula. This way, this is the best way to find the displacement vector if multiple displacement along the straight line are given. So there is a question on that, like whatever I have taught you till now, I'm going to ask a question on that. Okay, so question number 1 is based on that only. A person moves 30 meter north and then 20 meter towards east and finally 30 root 2 meter in southwest direction. So there are 3 different displacements are given to us. The displacement of the person from the origin will be. So there are 3 displacements which we have to add. There are 3 different displacements which we have to add, and we find the net displacement of the person from the origin. We have to find the net displacement of the person from the origin. So you want to solve it, you want to try it. So they are saying like somebody has already answered it, like Parul Yadav said like it will be 0. Will it be 0? Will it be 0? Let's try to solve this. So what did I tell you? Like when there are multiple displacements are given, what you can do is you simply add their x component, like break the displacement vector in its components and add those components. Okay, so let's say the east direction I am taking as the x-axis along the positive x-axis. Okay, eastward. North along the positive y direction. North is along the positive y direction. So this is y. Wait. So north along the y direction, east along the x direction. Okay. So what is the first displacement? That is along the north direction. And what is that amount of that displacement? That is the 30 meter. So it is moving 30 meter in the north direction. First, it has moved 30 meter in the north direction, 30 meter. Okay. Then it is moving 20 meter towards the east. So 20 meter towards the east. I can simply say the S2 vector is in this direction. You can parallelly shift a vector, it is not a problem. This is S2 vector and the magnitude of the S2 vector is 20 meter. This is the S1 vector. The magnitude of the S1 vector is 30 meter. There are these 2 displacement vectors. You say, sir, why are you drawing it from here? It should start from here. Particle is going like this. You know, in vector you have already studied if you parallelly shift a vector, it does not create any problem. So I have shifted that vector here. The other vector is in the east direction and it has a magnitude of 20 meter. I have just drawn it like that. And the third vector is towards the southwest. So west direction is this, south is this, southwest direction is this at an angle of 45 degree. So third vector is this and the magnitude of third vector is 30 root 2. This angle is 45 degree. Okay, got it? So what is the best way to solve this question? I'll say simply write them in terms of I cap and j cap. Solution is there. So S1 vector can be written like 30 j cap. S2 vector can be written like 20 I cap. These are the two vectors, S1 vector and S2 vector. S3 vector. S3 vector is, you will do the component of this. So this is this vector, the component of this in this direction will be what? And in this direction, we'll break it in component. The component of this 30 root 2 in this direction, and the component of the 30 root 2 in this direction will be 30 root 2 cos 45. It will be 30. Okay, we have component of this 30 root 2 sin 45. Again it will be 30. But this is negative x direction, this is negative y direction. So S3 vector will be minus ka 30 I cap, minus ka 30 j cap. Now you add all these vector, S1 vector plus S2 vector plus S3 vector. This is the best way to solve this kind of question. So when you add them, this and this gets cancelled out, and this will be minus 30 I cap plus ka 20 I cap, and the answer will be minus ka 10 I cap. So minus ka 10 I cap will be the displacement vector. So what is the I cap direction along the east? Minus I cap will be along the west. So 10 meter along the west will be the answer, and this is the correct answer of this question. Are you able to understand this? Are you able to understand this question? This question clear to each and every one of you? Is this question clear to each one of you or not clear? Not clear, sir, at all. Any response will help me if you want me to repeat this question. If you don't want to repeat me this question, then we will move to the next question. All clear? Repeat. What I've done is I have just taken x-axis along the east direction, y-axis along the north direction, minus I cap along the west direction, minus j cap along the south direction. So they say a person moves 30 meter in the north direction. So there is a displacement vector in the north direction. So can I write this displacement vector is equal to 30 j cap, because unit vector in the y direction is the j cap vector. So S1 vector will be 30 j cap. And I have already taught this, how do we create this kind of vectors in my third session, or it was fourth session. It was third session. In third session, I taught the vector on this channel only. And in that I have covered all these. So 30 meter in the north direction, 20 meter towards the east. So the other vector will be 20 I cap. And they are saying 30 root 2 southwest. Southwest direction is the direction in between west and south at an angle of 45 degree. So there we will have two component of this, 30 root 2 cos 45, 30 root 2 sin 45. So 30 in west direction, 30 in south direction. So this vector will be minus ka 30 I cap, minus ka 30 j cap. Got it? And I have just added all these three, and I got minus ka 10 I cap. So minus ka I cap is the west direction. So 10 meter along the west direction will be the answer of this question. So C option is the correct option. This question we cannot solve right now. Okay, let's talk about the average velocity and the speed. Okay, this is also very important concept. Like most of the time the questions are asked from this part only. Like if you go and see the PYQ on this topic, you'll find most of the question are on the average velocity. So what is this average velocity? Average velocity and average speed, they are very, very important concept. So here we'll talk about the average velocity. I draw a line here. Let's make this line a white line. Oh no. This line changes its color. One more parameter we are going to define. And these two parameters are called the average velocity and the average speed. So this is the average velocity. Average velocity. And this one is the average speed. So average velocity and average speed, there are two very important concepts. It should come a little bit downward. It should go a little bit upward. downward. Okay, now it is fine. So average speed and the average velocity, these are two very important terms. So let's say a particle is moving like this. A particle is moving like this. First it traveled L1 distance in this direction, and then it traveled L2 distance in this direction. Okay. So this is the final position, this is the initial position. Initial and the final. This is L2, this is L1. So we draw these lines with some other color. L2 and this is L1, and total time taken is T naught. So this is L1 and this is L2. Particle started at t equal to 0 and reach this position at t equal to t naught. Okay, so final position is at t equal to t naught. At t naught time, particle reaches this position. Okay, particle went like this. So there is a formula for average velocity. Average velocity, which we write like this, or we represent like this. They both are same thing. Okay, they both are same thing, average velocity. So average velocity is written like displacement divided by time taken. So average velocity is displacement divided by time taken. It's called the average velocity. So average velocity definition is clear to each and everyone. Average velocity is displacement divided by time interval. So displacement is a vector. So average velocity is also a vector. Average velocity is a vector. Average velocity is a vector in the direction of displacement. Average velocity is a vector in the direction of the displacement. It is a vector. Okay. So here average velocity will be equal to L1 minus L2 divided by delta t, because displacement in this case is equal to L1 minus ka L2, and the direction of the average velocity will be this. What is the formula of the average speed? Average speed will be like this or like this. These all are average speed representation. For average we use this symbol. For average we use this symbol. So what is the formula of the average speed? It is distance divided by time interval. So average speed is distance divided by, what is happening? Distance divided by time interval. Average speed is distance divided by time taken. Okay, so average speed is distance divided by time taken. That is called the average speed. It is a scalar physical quantity. It is scalar physical quantity. It can never be less than, it can never be less than, it can never be less than magnitude of average velocity, or you say it is always greater than or equal to magnitude of the average velocity, because again we are comparing the distance and the displacement. In this case, the average speed is L1 plus ka L2 divided by delta t. In the previous case, the average speed is L1 plus L2 divided by delta t. What is happening? Logi. So average velocity we have defined, average speed we have defined, they are defined like this. Average velocity and average speed are defined like this. There is a very, very important concept, and that is in terms I'll cover that with an question. Okay. A particle travel half of the total distance. A particle travel half of the total time with velocity v1. Oh no. Same question is repeated. A particle travel half of the total distance, not time. Let me do some correction here. Remaining half of the total distance with velocity v2. So a particle travel half of the total distance with velocity v1, and remaining half of the total distance with velocity v2. Then find the average velocity of the particle if particle moves along the straight line without changing its direction. So this particle is moving along the straight line without changing its direction of motion. A particle travel half of the total distance with velocity v1 and remaining half of the total distance with velocity v2. Then find the average velocity of the particle if particle moves along the straight line without changing its direction of motion. Can you answer this question? Can you answer this question? So how do we solve the question like this? How do we solve the question like this? So let's say total distance is, total distance is 2d. Okay? Can we say the total distance is 2d? Yes, we can say the total distance is 2d. Why I have taken 2d distance? Why not d? Because half distance will be d then in that case. So let's say this total distance is 2d. Particle is traveling from A to B. Particle is going from A to B. Total distance is 2d. So what will be the half distance? In that case, the half distance will be only d. Wow. Okay. Half distance, the remaining half will be again d. So half of distance are d and d. So this distance is d. This distance is also d. Okay, these are d. This d distance is traveled by v1 speed, and the remaining d distance is traveled by v2 speed. Got it? First d distance is traveled by with v1. The next d distance is traveled with v2. What is the concept of the average velocity here? What is average velocity? What is average velocity in this case? So you'll say, sir, total displacement, or particle is not changing its direction, so total distance divided by total time. This will be the average velocity. Got it? Okay. What is the total distance? 2d. Particle is traveling, total distance is equal to 2d. This first d distance is traveled in time t1. Can I write t1 is equal to d divided by v1? And the remaining d distance is traveled in time t2. Can I write T2 is equal to D divided by V2? They'll say, yes, sir, you can write like that. So total time in traveling 2D distance will be T1 plus ka T2. So 2D divided by D divided by V1, D divided by V2. So the average velocity becomes 2 V1 V2 divided by V1 plus V2. So average velocity is equal to 2 V1 V2 divided by V1 plus ka V2. So is this clear to each and everyone? Like this concept is clear to everyone? Concept clear to everyone. So you can directly use this formula if total half of the total distance is traveled with V1 and remaining half is traveled with V2. Okay. So there is one more question. A particle travel half of the total time with V1 and remaining half of the total time with V2. Then find the average velocity of the particle if particle moves along a straight line without changing its direction. So if particle travel total, like average velocity we have to find if particle moves without changing its direction. So a particle travel half of the total time with velocity v1, half of the total time with velocity v2, then find the average velocity of the particle if particle moves along the straight line without changing its direction. Can you solve this question? Okay, let's solve this question. So guys, let's say from A to B, particle has to travel in time t. This is point A, this is point B. It is started from point A at t equal to 0, reaches the point B at t equal to capital T time, okay? Capital T time it is reaching B. Half of the time, let's say half of the time is this time, t by 2. Particle was at this point. So in half of the time, particle must have covered some distance because it is traveling with v1. In other half of the time, it has covered some distance. So in this time and in this time. In this time, let's say it has covered x distance. In this time, y distance, because distances will be different in this case. Why? Because speed is different, na? v1 and v2. Time is same. This time and this time is same, but the speed is different. So in same time, it will travel different distances because speed is different. Okay, so x is equal to v1 into t by 2. Y is equal to v2 into t by 2. X and y clear to you. So x and y is clear to everyone. X and y clear to everyone. How do I find the x and y? X distance and y distance. So average velocity is given by this formula. Average velocity is equal to total distance. Here I am not writing displacement because distance and displacement both are same if particle does not change its motion, direction of the motion, divided by total time. So can you see total distance is x plus ka y and total time is capital T. So now I can write x, which is v1 into t divided by 2, y, which is v2 into t divided by 2, divided by t. So average velocity becomes v1 plus ka v2 divided by 2. Let's fill it. Okay, this is the answer. So in this case, answer is this. So v1 plus ka v2 divided by 2 is the answer. v1 plus ka v2 divided by 2 is every concept. I have covered 4 questions till now. Clear to each and everyone attending the class from the beginning. There is one more question, and this kind of questions generally asked in the your NEET exam. So a person travel along a straight line road for the half of the distance with velocity 10 meter per second, and the remaining half of the distance with velocity 20 meter per second. Find the average velocity given by. So this is very easy question. Do you want to find the answer of this question, or you just want to wait and watch? The other option is not good for you, good for your health, good for your preparation, good for your anything. So do you want to solve this question, or you want to just wait and watch? I hope you all are solving this question and you have already liked the session. Liking the session is very important. (40/3). You got the answer. Very good. Some of the students are still trying to find the answer of the question. So this formula we will use: V1 V2 divided by V1 plus ka V2. V1 plus ka V2. So this answer is 2 times. V1 is 10, V2 is 20. It comes out to be 10 plus ka 20. So the final answer is 40 divided by 3 meter per second. D option is the correct option. Will you be able to solve this kind of questions? Yes, D option is the correct option. You can see again, D option is the correct option. Okay, so there is question number 6. A car travels from A to B at a speed of 20 km per hour and return at a speed of 30 km per hour. A to B, or return at a distance of like speed of 30 km per hour. The average speed of the car for whole journey is. What is the average speed of the car for the whole journey? What is the average speed of the car? What is the average speed of the car? Average speed of the car for the whole journey. So say, suppose this is the distance, this is a point A, this is point B. The total distance between both A and B is D. So car goes with 20 meter per second and came back with 30 meter per second. So they are asking the average speed. So average speed is total distance. Here distance and displacement are not equal in this case. Divided by time taken. Okay, total distance divided by time taken. So average speed will be, distance is D plus D. It went D distance and then came back D distance. Time is, when it is going, it takes D divided by 20 second. When it is coming back, D divided by 30 is the time taken. So it has to cover the D distance with 20 meter per second. So the time taken will be D divided by 20. When it is coming back, D distance with 30 meter per second. So time will be D divided by 30. It will be 2 divided by 60. 3 plus ka 2, 5. 24 meter per second will be the answer. 24. Oh, so they are saying kilometer per hour. Kilometer per hour. Kilometer per hour. 24 kilometer per hour will be the answer. B option is the correct option. It is easy question. Do you find this question easy? Done. Done. Question number 6 is done. Okay, now we move to next concept, and that is called the concept of the velocity. We have solved 5 questions only. It is saying question number 6, but we have already left one question of the distance. We will go to that question. once we talk about the velocity. What is velocity? Velocity. This is a very important term, okay? Let's talk about the velocity. Oh. So velocity. Time rate of change of time rate of change of position vector or displacement vector. Time rate of change of position vector or displacement vector is called velocity. So what is velocity? Time rate of position vector or displacement vector is called the velocity. So there are three type of questions are given on the velocity. Three type of questions. So case 1. If x, which is the position, or s, which is the displacement, is given as function of time. So somebody gave you x or s as a function of time. So somebody says position is given as 2t square plus 1. Like somebody gave you like this. The position of the particle is given like this. So this is called the x as the function of time. So to find the velocity, just differentiate x with respect to time, or find the velocity, just differentiate displacement with function of time. This is the way we find the velocity. So if x is given as a function of time, just differentiate that with respect to time and you get the velocity. Case 1 is clear to each and everyone. What we do? Position or displacement is given as a function of time, then just differentiate them and you get the velocity. Time rate of change of the position vector is called the displacement, or the displacement is called the velocity. So velocity is nothing but it is the rate of change of the position or rate of change of the displacement. Okay. So first case is clear to each and everyone. There is a case 2. Sometimes what is given to you? Nothing is given to you. So case 2 is if x versus t or s versus t graph is given. Graph is given. What is given? X versus t or s versus t. Suppose something like this is given. X versus t. Like this. Slope of tangent on x versus t or s versus t gives us velocity. Okay. So slope of tangent on these two curves gives us velocity. Like I can draw the tangent at few points. At this point, tangent will be like this. At this point, tangent will look like this. At this point, tangent will look like this. At this point, tangent will look like this. There are few points. This point is A, B, C. This point is D. So at point A, velocity is equal to 0. At this point, tangent is flat. At point B, velocity is negative. So let's say this direction is positive, velocity will be negative. At point C, again velocity is 0. At point D, velocity is positive. So slope of the tangent, or you say simply like you define this angle as theta. So velocity at D will be equal to tan theta. Slope of the tangent is given by it will give you velocity. So when this, either this kind of question will be given to you or this kind of question will be given to you. Or there is a case 4 as well. All the question that can be asked on the velocity part, I'm going to cover here only. Or case 3 is sometimes velocity is given to you. Okay. Case 3 is velocity as a function of time is given to you. If velocity as a function of time is given to you. So whenever you are solving a question of velocity, okay, and you get stuck in that question, just come to this slide and you will definitely find the question, answer of that question in this slide or in the next slide. In these two type of question, whenever there is a question of velocity, you will be definitely able to solve that question with the help of these two slides. What else I can say? So sometimes velocity is given like t square plus 1, something like this, for example. Okay, if velocity is given like this, then displacement is the integration of the velocity. You just integrate the velocity, put the limit, you get the displacement. So if velocity is given, they will ask the displacement. If displacement is given, they will ask the velocity. So with this, when you differentiate displacement, you get the velocity. When you integrate velocity, you get the displacement. Integration and the differentiation both are inverse function of each other, no? You get displacement like this. Average velocity, if they ask average velocity, it is displacement divided by time interval. So displacement is v dt divided by delta t. So if this kind of, I am saying each and every question on velocity can be answered after watching these two slides, next one also. So if they ask average velocity, they give that question, you do that. They give this question, you do this. They give this question, you do this. This, that, this, that. Let's put this in a box. This is very, very important. Very, very important. Okay, you're done. How do we find the velocity? By doing this. On the next page, there is a very important term. Sometimes people, so there will be case 4 as well. But before that, I am going to teach you one very important term. Look, okay, case 4 first. So what does this case 4 says? Is there anything special about this? Yes, there is a lot special about this. V velocity versus time graph is given. Velocity versus time graph is given. What they did? They gave you velocity versus time graph. And what you did? You just said, sir, velocity versus time graph is given to us. Not like this. So let's say velocity versus time graph is given to us like this. Okay. So this is velocity versus time graph. V versus t. So area under velocity versus time, and write one thing with a sign, gives us displacement. Area all taken positive, gives us distance. Okay, so if you take without sign, then it will give you distance, and if you take area under the velocity versus time curve with sign, it will give you displacement. Let's say this area A1 is 10 unit, this area A2 is 80 unit magnitude wise. Here velocity was positive, here velocity is opposite direction, negative. So this is negative displacement, this is positive displacement. So when you write distance here, you will say A1 plus A2. So distance comes out to be 10 plus 8. So distance will be equal to 18 meter. But displacement 10 minus 8, 2 meters. Displacement will be 2 meter. Is this clear to everyone? Why this cola varidi? Okay. So why did I write 10 minus 8 displacement? Because here motion is like velocity is positive, particle is going in this direction. So this area is 10 units. So particle went 10 meter in this direction. Now velocity has changed its sign. Now particle is coming back, and it has covered area 8 unit. So it has come back 8 meters. So the displacement will be 10 minus 8. It will be 2 meter. But distance will be 10 plus 8. It will be 18 meter. 18 meter and 2 meter. Is this clear? Both clear, not clear, or nuclear? Sir, it's not clear. It's nuclear. When it is not clear, it is called nuclear. Eh? So there is one more term. You have heard about this term. That's why I am not going to talk about this term, because you already have heard about this term. And this term is called the speed. Can anyone tell me what is the speed? Speed. So this is a very important and very easy term. Magnitude of velocity is called the speed. Magnitude of velocity is called the speed. Speed is nothing but directionless velocity is called the speed. Speed is a scalar. Speed is scalar. Okay. And if speed is constant, then distance is equal to speed into time, if it is constant. Or distance is equal to integration of the speed with time. Or distance is equal to, so it is magnitude of the velocity, na? Okay. These are all the formulas of distance. Done, 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 done. Okay, speed, velocity, everything I have covered till now. Velocity, distance, this, that. Okay, so there is a very easy question on velocity, and you can very easily can answer this question. The displacement of the particle starting from the rest is given by 6t square minus t cube, the time in second at which the particle will attain zero velocity again. When the particle will attain the zero velocity again, when this particle will attain the zero velocity again, speed can never be negative. Speed can never be negative. Speed can never be negative. Okay, so displacement vector is given. So this belongs to which case? This is case 1. When s as a function of time is given, you have to identify the cases. Just identify which case is given to you. Case 1 is this: s as a function of time is given. What do you do to find the velocity? You simply differentiate displacement. So velocity comes out to be differentiation 12t. When I was teaching the differentiation, many of you were missing at that time. So don't do that. Just go and watch this differentiation and integration part, which I have covered in the vector class. Along with the vector, I have covered the calculus part. So velocity is 0. That means t, let's take 3t common, 4 minus ka t is equal to 0. 3t square, 3t common. So velocity is 0 when t equal to 0 or t equal to 4 second. At t equal to 4 second, the velocity is 0. Velocity is 0 at t equal to 0 second and the 4 second. So B option is the correct option. B option is the correct option. B option is the correct option. Question number 7 clear. 8 clear, 7 clear. Let's go to the last question that we have already left there. Question number 2. Can you find the distance traveled by the particle? Can you find the distance traveled by the particle? The position of the particle moving along the x-axis is given as this. Then the distance traveled by the particle from 0 to 2 seconds we have to find. Distance traveled by the particle in 0 to 2 seconds we have to find. 0 to 2 seconds. 0 to 2 seconds. Distance traveled we have to find. No, we don't have to find. You have to find. You find distance traveled by the Can you find the distance traveled by the particle? Did you like the session? Then like the session. If you like the session, you have to like the session. You like this session, you like there as well. So there are 2 sessions. One is this, other is in front of you on the YouTube. You like the YouTube session as well. Those who are watching the recording, they also are supposed to like and comment. Don't forget to comment your experience with the class. Like, are all your doubts clear after watching this video? Don't do conjusi, okay? Conjusi, you understand? When you try to hold something up to you only, like conjusi. How do I explain conjusi? I've learned a lot of English, like while teaching you. Like I'm quite fluent now. Earlier I was facing a lot of problem. In the last class, I had to explain the rail track bending situation. I could not recall what is we called to that railway track. Now I know, but I got stuck there in previous class. Okay, so position of the particle moving along the x-axis is given like this. So the distance traveled. So there what they are asking. They are asking distance. Can I directly answer this? No, distance means red alert. You have to be very alert. Whenever somebody asks you distance, you have to be very cautious. Why? Because distance is a scalar. You have to track the path of the particle. You cannot directly answer by putting the value in this. So what is the position at t equal to 0? Where was the particle? So you will put that t value 0. It comes out to be 2. So particle started its motion from here. Where is the particle at t equal to 2 second? So at t equal to 2, you put 2 in that equation. 8 into 2 minus ka 4 into 2 ka square. The position of the particle at t equal to 2 is 16 plus 2 minus ka 16. So it is 2 again. So particle started from 2 and it is at 2 meter per at 2 meter after 2 seconds. So what is the displacement of the particle? Final x coordinate minus initial x coordinate. Displacement is the change in the position vector, that is 0. But the problem is, what is the problem here? The problem is they are asking the distance and this does not give you the distance. So to find the distance, you have to make sure particle is moving in only one direction. And direction is given by the velocity. So first you find the velocity. So whenever distance is asked, always find velocity. So velocity is dx divided by dt. And this comes out to be 8 minus ka 8t. Okay. So velocity can be written like 8, 1 minus ka t. So when t is less than 1, velocity is positive. When t is greater than 1, velocity is negative. At t equal to 1, at t equal to 1 second, velocity is changing its time. Velocity is changing its direction, not time. So velocity is changing its direction at when? At x equal to t equal to 1. At t equal to 1, velocity is changing its direction. So what is the position of the particle at t equal to 1? So put t equal to 1 in this equation. This is 2 plus 8 minus ka 4 into 1 ka square will be 1. So it is 6 meter. So particle started from where? At x equal to 2, at t equal to 0. It went where? There. It went to at t equal to 1 at x equal to 6. Then came back. This is the path of the particle. So what is the distance traveled? From x equal to 2 to 6 and 6 to 2. 4 meter, 4 meter, 8 meter will be the answer of this question. 8 meter will be the answer of this question. Why did I say you have to be very cautious when solving the question of distance? Because distance questions might get you trapped. Okay. In case of the distance, you cannot directly solve question by just simply finding the position of the particle at 0 and position of the particle at t equal to 2. You have to track the path of the particle. Path of the particle is important. Okay. You will say particle started from here, went there, and then came back. Whole path you have to track. Only then you can answer the question of the distance. So is this clear? Clear? I have already taught you the average velocity, speed. So from where we started. Okay. Today the notes are very beautiful. See, We started from here, kinematics, motion. I defined motion and kinematics, everything, displacement, distance, everything about the distance and displacement. These wonderful illustrations we have already done. The resultant of the displacement, this case I have already taught you. We covered the question on that. And the next question, which is on the distance, which is a very tricky part of the motion parameter, that we covered. Average velocity, average speed, everything about them I have covered. We solved two very beautiful questions. These are the beautiful questions. One most frequently asked question in the exam. One similar type of question. And then we talk about the velocity. All the cases, what type of question can we ask on the velocity? I have covered here. Everything about the speed, we solved a question as well. And now we move to the very important parameter, and this parameter is called the acceleration. So next parameter is the acceleration. Now we are going to talk about one more parameter, that is the acceleration. Kindly don't forget to like the session, okay? We could not, I think, how many likes are there on the session? Only 177. This is very sad. It should cross 300 by the end of the session. So acceleration I am going to talk about. Next concept is acceleration. And this is a very beautiful concept actually. You'll come to know so many new things about the acceleration. What is acceleration? Time rate of change of velocity. Time rate of change of velocity. Time rate of change of velocity is called acceleration. Time rate of change of velocity is called the acceleration. So there are two formulas of the acceleration. A is equal to dv divided by dt, or A is equal to v into dv divided by ds or dx. Okay, these are the two very important formulas of the acceleration. Very important formulas of the acceleration. So acceleration is time rate of change of the velocity. So rate of change of the velocity is called the acceleration. So acceleration changes the velocity. Okay, acceleration changes the velocity. Again, there are also similarly few cases which we will talk about one by one. What type of question can we ask on the acceleration? What are the types of the question that can we ask on the acceleration? So first case is just we are about to start. So case 1, what kind of question can we ask on the acceleration? So case 1, what is case 1? If velocity is given as function of time. So most of the time velocity is given as function of time, and they ask, let's say velocity is given like this, t to the power 3 minus 2t square. So this is called the velocity is given as a function of time, and they ask you acceleration. Find the acceleration. What do? Write here velocity or position. Velocity or position are given as function of time. Are given as function of time. So to find the acceleration, you just differentiate velocity, okay? dv by dt. Or what you do? First find the velocity by differentiating once x, and acceleration can also be written like d2x by dt square. So double differentiation of the position gives you acceleration. Single differentiation of the velocity gives you acceleration. These are the two ways to find the acceleration. So either position will be given as a function of time, or velocity will be given as a function of time. So if velocity is given as a function of time, you differentiate once and you get the acceleration. Position is given as a function of time, you differentiate position as twice, and then you get the acceleration. So this was the first case. This was the case 1. There is case 2. What does this case say? What are the other type of question that can be asked? Case 2. Bata दूं? Yes. So this is case 2. Case 2 is if velocity is given as function of position. If velocity is given as function of position, v is given as function of x, then acceleration is equal to v into dv divided by dx. This is the way we find the acceleration. Okay, this is the other type of question, case which can be asked in the exam. Two type of question that can be asked in the exam. Let's move to the case 3. Case 3 is if velocity versus should we go to that side? No, we can cover one more case. Velocity versus time graph is given. So what they gave? Velocity versus time graph. So slope of tangent on v versus t gives us acceleration. Okay. So slope of tangent on v versus t gives us acceleration. What are the fourth type of question that can be asked on the acceleration? I'm going to, I told you, just like in case of velocity. Similarly, all the questions which are related to acceleration can be related with these cases. Like I'll cover each and every concept. So case 4, what other kind of question can we ask on this? If acceleration as a function of time is given, sometimes acceleration is given as a function of time, okay? So dv divided by dt is the acceleration, and this is given. Now this is not given. So dv is equal to a dt. So by integrating acceleration, you get final velocity vector minus initial vector is equal to integration of the acceleration. So this is called the change in velocity vector. So change in velocity vector you get for simply by integrating. Oh no. This is creating the problem. No. No. You don't create the problem. So how do you find the change in velocity? By simply integrating the acceleration. So integrate the acceleration, you get the So can you come on finding the velocity when time is given as a function of position? Yes. That okay. On your special demand, if there is some question given like t equal to x is let's say root x plus 1, something like that. Yeah, or say this. You have to just find, to find the velocity, you have to just find the dx by dt. So differentiate this equation with respect to time. So when you differentiate time with respect to time, it will be 1. And the differentiation will be of this will be 1 upon 2 root x dx by dt. This is velocity. So velocity will be equal to 2 root x. You can write root x from here to t plus ka 1. See, there will be only the problem will be if you understand the chain rule of the differentiation, you will be able to solve that question. Those questions are difficult just because you don't understand how to apply a chain rule, and that I have taught you in the differentiation class. That's why I said like basic mathematics is the base or core of physics. Like you understand basic maths, you have a strong grip on that, you will never face a problem in physics. Done. So we have touched 191 likes. Acceleration position graph gives you, okay, I'll talk about that also. No, like we have covered only how many cases? 4 cases. So this acceleration, velocity function of time is given, x function of time is given, 1 differentiation, acceleration, 2 differentiation, acceleration. Velocity as a function of x is given, v dv by dx will give you acceleration. Velocity and time graph is given, slope of tangent will be acceleration. Acceleration is given, change in velocity will be the integration of the acceleration. So next, on the next page, we talk about that. So what was your question? If acceleration as a function, like, so 5th case, I'll cover all the cases. Oh no. Nope. I don't have that much space. Okay. It would be your best class on the rectilinear motion in your life. Like you can compare this class with any class you have watched till now. The detail I have covered are unmatchable. Like you'll be able to relate any question of your sheet with the concepts covered in this. So case 5 is there. Case 5 says if acceleration as a function of x is given, sometimes this is given. Is there any example of that acceleration is equal to minus ka omega square x in SHM? SHM we have studied this, na? Acceleration as a function of x. So if this is given, then we use this formula, a equal to v into dv divided by dx. So v dv is equal to a dx. We integrate it, so v square divided by 2 minus ka u square divided by 2 is equal to integration of a dx. Okay, so v square minus ka u square you get 2 times integration of a dx. So this will be the formula. You can find velocity if acceleration as a function of x is given. This will be the case. Okay, case number 5 is clear to everyone. If acceleration as a function of x is given, you can find the velocity from here. If initial velocity must be given, the initial velocity must be given to you. Okay, there is one more case, and that is, there is one more case, case per case. So this is case number 6. 6th case. If acceleration versus time graph is given, so they gave you acceleration versus time graph. Let's say this kind of graph is given. Like this. And this is acceleration versus time. So area under A versus T, area under A versus T. You always take this with sign, gives us change in velocity. Okay, change in velocity it gives us. So if you want to find the average acceleration, that is area A versus T divided by time. I'll cover that as well. So what is the formula of the average acceleration? Average acceleration is the change in velocity divided by time interval. So change in velocity is the area under acceleration versus time curve. You'll get the average acceleration is equal to area A versus T divided by time. This was the case 6. So acceleration time graph is given, area under the curve will give you the change in velocity. Acceleration time graph is given, area under the curve will give you the change in velocity. Okay. I think all the cases we have covered till now, like now I'm going to tell you a very, very important concept of this. Like we can again, if a graph of A versus X is given, so this is area under A versus X. So V square minus U square is equal to 2 times area under A minus A versus X. That you can relate from here. That you can relate from there. Now this is a very special case. Very, very special case. Understanding acceleration. What does actually acceleration do? What does actually acceleration do? And you are going to visualize the acceleration. So understanding acceleration. What does actually acceleration do? We are going to understand it, okay? Understanding the acceleration. So what is the definition of the acceleration? So acceleration is equal to dv vector divided by dt. This is the acceleration. This is the acceleration. So if I write dv vector, it is equal to a vector into dt. This is the change in velocity vector in dt time. So change in velocity vector in dt time is given by dv vector. So v final minus v initial is called the change in velocity. So in dt times, velocity becomes initial velocity vector plus dv vector. Okay, is this clear? Do I have written something which is not clear to you? Do you find it difficult? No? What I've written? I said dv vector is the change in the velocity vector in dt time. So v after dt time minus ka v at time t is equal to dv. So v after dt time will be equal to, okay. Let me explain it in another way. So you have 10 rupees and I give you 1 more rupees. What will be the final amount on you? You have, that is the 11 rupees. You'll say, sir, you gave me 1 rupees. I already had 10 rupees. Now I have different amount. That is the final value after giving 1 rupees. So initial amount you had was 10 rupees. I gave you 1 rupees. Now you have 11 rupees. Okay. 11 rupees is the final value. 10 rupees is the initial value. And the difference which I have given to you, that is the 1 rupees. Is this clear? आवाज clear नहीं है? Okay. Wait. Let me check. Hello? Hello. Let me check. Everything is clear, yaar. Like there is no problem. Hello? There is no such problem. Sound is clear. Listen again. So, what is the change in any vector? Final value minus initial value is the change in vector. Final value minus initial value is the change in the vector. That is called the vector change. So I said, what is acceleration? Change in velocity divided by time interval. But that time interval is very small. That's why we call dv by dt. So acceleration is equal to dv by dt. dv is the, basically dv is what? dv is the small change in velocity in dt time. So this is the change in velocity vector in dt time. So I am saying velocity vector after dt time becomes v final. Earlier it was v initial. And difference of both is equal to delta v. Difference is delta v. So I take this vi vector on the other side and I get velocity at time t plus dt is equal to velocity at time t plus ka dv vector. So velocity at time t plus ka dt is equal to velocity at time t plus ka acceleration into dt. So this will be the velocity after time dt. You just add a dt in the velocity and you get velocity after time dt. So this vector will be in the direction of the acceleration. So if velocity is in this direction and acceleration is also in this direction, if a particle has velocity and acceleration in the same direction, so particle's velocity is in this direction, acceleration is also this direction, the magnitude of velocity will increase because this term will get added into this velocity. So this is called particle will speed up. In this case, particle will speed up. Speed up. So particle will speed up. So dv vector divided by dt is equal to a vector. Here d mod v vector divided by dt is also equal to a. Because rate of change of speed is equal to acceleration. This acceleration is called the tangential acceleration. When velocity and acceleration are in the same direction, particle will not change its direction. It will speed up. When acceleration and velocity are in the same direction, particle will speed up. When acceleration and velocity are in the same direction, particle will speed up. Rate of change of speed will be equal to acceleration. And that mod of velocity, that is called speed. So rate of change of speed and rate of change of velocity. On the left hand side I have written rate of change of velocity. On the right hand side I have written rate of change of speed. So this is called rate of change of speed and this is called rate of change of velocity. So rate of change of velocity is acceleration. Rate of change of speed is equal to here acceleration, because acceleration is in the direction of the velocity and it is changing the speed. But if acceleration and velocity both are opposite to each other, acceleration and velocity both are opposite to each other, velocity vector is in this direction, acceleration is in this direction, particle will slow down. Particle will slow down. Now it will decrease the speed of the particle. Third case, if velocity and acceleration are perpendicular to each other, they both are like this. Velocity is in this direction, acceleration is in this direction. Now speed will not change if they continue like this. D of mod v, which is speed of rate of change of the speed, will be 0. This is called the rate of change of speed. Rate of change of speed. This will be equal to 0. But dv vector divided by dt is equal to non-zero. The direction of motion will change. The direction of motion will change. So here the direction of motion will change. Here magnitude of the velocity will not change. Speed will not change. Speed remain constant in this case, but the direction will change. So whenever acceleration and velocity are perpendicular to each other, this term will be 0, but this will not be 0. You will say, sir, what is the difference between both? Here, this is the rate of change of velocity, which is acceleration. So acceleration is non-zero. There is acceleration that is perpendicular to velocity. What is this term? This is d mod of v. Mod of v means speed. Mod of v means speed. So speed का rate of change is rate of change of speed. Speed is not changing in this case. Speed changes if acceleration is in direction of velocity or acceleration is opposite to velocity. Speed changes when acceleration is perpendicular to velocity. Speed does not change. So mod of v, rate of change of mod of v, which is the rate of change of speed, will be 0. But there is acceleration which is changing the direction of the velocity. Ultimately somebody is there to change the velocity. So there is acceleration, so acceleration is non-zero, but rate of change of speed will be 0. Got it? I hope you all are going through this for the first time. This is new to you. Is that clear? Here they both are equal. Here dv by dt, this will be minus a because speed is decreasing. Here dv by dt, d mod v by dt will be 0, but dv by dt will not be equal to 0. So rate of change of speed is 0, but acceleration is there. So acceleration, the perpendicular component of acceleration to the velocity changes the direction of motion. The component of acceleration which is perpendicular to velocity changes the direction of motion. So in uniform circular motion, when particle is performing circular motion with constant speed, speed is not changing, then acceleration is perpendicular to velocity and acceleration is towards the center. But when velocity, when the speed is changing, when non-uniform circular motion, when particle speed up on the circular path, it has tangential acceleration as well. That tangential acceleration changes the speed. The acceleration parallel to velocity or anti-parallel to velocity changes the speed. But acceleration component perpendicular to velocity changes only direction. Is this clear to everyone? Understanding of acceleration is clear to everyone? Are you able to understand this? This part. So I can add one more slide here. I can add one more slide. So what if particle has a velocity in this direction and acceleration in this direction? This is the acceleration, this is the velocity, this is angle theta. So what we will do is, we will do the component of the velocity in the direction of acceleration perpendicular to acceleration, okay? This component is called the tangential acceleration. This is equal to a cos theta. Component of acceleration along the velocity is called tangential acceleration, and this is called the normal acceleration, which is a sin theta. A cos theta is responsible for speed change. So this is equal to dv by dt. This. And a is equal to velocity change. So when you write dv by dt, that will be equal to a. So dv by dt is a. But d mod v by dt is this. And this is called the tangential acceleration. This is called the tangential acceleration. Rate of change of speed. This is responsible for rate of change of speed. So rate of change of speed is the tangential acceleration of the tangential acceleration, which is the component of the acceleration parallel to velocity, that is responsible for the speed change. Velocity change is equal to net acceleration. In this case, what will happen? Particle will speed up and change its direction. Particle will speed up in this case, and its direction will change. Its direction of motion will change. Its direction of motion will change. Its direction of motion will change. So particle will speed up and direction of motion will change. Particle will speed up and its direction of motion will change. What if acceleration and velocity have 90 degree angle greater than 90 degree, like this? So velocity is in this direction, acceleration is in this direction, and angle between both is greater than 90 degree. particle will slow down. Particle will slow down. The particle will slow down and its direction will change, and its direction will change. Why so? The component of acceleration will be in this direction and one in the perpendicular direction. So whenever velocity and acceleration are perpendicular, when velocity and acceleration are perpendicular to each other, the direction of the velocity changes. When they are in the same direction, particle speed up. When they are opposite to each other, particle slow down. Got it? Got it? Is this clear to everyone? Acceleration, everything about acceleration is clear to everyone. Now let us talk about let us solve this question. The acceleration a in meter per second square of a particle is given by a equal to 3t square plus ka 2t plus ka 2, where t is the time. If the particle start out with a velocity u equal to 2 meter per second at t equal to 0, then the velocity at the end of 2 seconds is velocity at the end of the 2 second. Oh, 1 minute. Is this question okay? Yes. So acceleration is given here and they are asking velocity at the end of the 2 second. Initial velocity is 2 meter per second. So initial velocity is given. They are asking the velocity at t equal to 2 second. You have to find the velocity at t equal to 2 second. So what is given to us? Acceleration as a function of time is given to us. So which case is this? So you go back and you try to relate. Acceleration as a function of time is given and they are asking velocity. So you have to integrate acceleration and you get the velocity vector. It is very easy, na? Like once you are able to relate this, that so final velocity minus initial velocity is equal to integration of a with the time 0 to 2 second. So final velocity we have to find. Initial velocity is given as 2 meter per second. This is equal to acceleration is 3t square plus ka 2t plus ka 2 dt. So v minus ka 2 is equal to t की power 3, 2 की power 3 plus t square means 2 का square plus 2t. I have directly put the value of 2, मतलब t. So v minus का 2 is equal to 8 plus का 4 plus का 4. So v equal to 16 plus का 2, v equal to 18 meter per second. Are you able to solve this kind of questions now? Answer will be B option. You have to just relate which type of question, which case they are asking, which question, what they are asking in the questions. You have to just relate it. And I was able to relate it with the case. Which case was there? Fourth case. I could directly relate it with case 4 and I am able to find the answer of this question. 18 meter per second. B option is the correct option. Done. Easy. We have one more question. Starting from the rest, acceleration of the particle is given. Velocity of the particle at t equal to 5. Again, the same case. Acceleration function of time is given. Asking the velocity. Can you solve this? Yes, sir. I can solve this. And they have given here one. Yes. After this, like just before starting the motion with uniform acceleration, I'll give you a 15-minute break. Okay. So just wait for 5 to 10 minutes only. 5 to 10 minutes. Just 5 to 10 minutes. Give me 5 to 10 minutes. I'll give you a break. I am also tired. Like for last 2.5 hours, I am continuously teaching now. So starting from the rest, acceleration of the particle is a equal to 2t minus cut 1. The velocity of the particle is, okay, let's solve this question. So what is acceleration? 2t minus ka 1. What is given? Acceleration as a function of time is given. So Which case is this? Case number 4. What we do in that case? We integrate this. We integrate v final minus v initial is equal to acceleration integration 2t minus ka 2 dt. For 0 to 5, initial velocity is given 0. They are saying particle started from rest. So initial velocity is 0. So velocity at t equal to 5 comes out to be t square minus ka 2 into 5, 25 minus ka 10. The velocity at t equal to 5 will be equal to 15 meter per second will be the answer. 15 meter per second is the answer of this question. Question number 9 is done. 15 meter per second is the D. A. B. DAB. DAB. A will be the answer, not D. Okay. There is a concept of average acceleration. I'll start motion with uniform acceleration after the break, okay? Before that, we have to cover all the concepts. Now, at least motion parameter we have to complete. So what is called the average acceleration? Average acceleration is very easy to understand. Average acceleration can be written like this also. Average acceleration is like this. Okay. Average acceleration is change in velocity vector. Change in velocity vector. Always remember this. Change in velocity vector divided by time interval. Change in velocity vector divided by time interval is the average acceleration. This is the way we find the average acceleration. V final vector minus ka V initial vector divided by delta t. This is called the average acceleration, okay? This is the definition of the average acceleration. Do we have any other way to find this? See, sometimes acceleration as a function of time is given, like in previous questions. So if acceleration as a function of time is given, then average acceleration is equal to change in velocity is integration of acceleration a dt divided by delta t. This is the one more way to find average acceleration. One more type of question that can be asked. If a versus t curve is given, acceleration versus time curve is given, so average acceleration is given by area under a versus t. Area under a versus t divided by time interval. This is also the a versus t. Okay. These are the all three type of question that can be asked on this average acceleration concept. A is given as a function of time. If a is given as a function of time, okay, so A is V final minus V initial divided by delta t, and this is the average acceleration concept. There is a one very important concept, and you have to only remember the formulas of this. Okay, I just want you to remember the formula of uniform circular motion. So if a particle is performing circular motion of radius r, this is the x-axis. So let's say particle started from here, initial position, initial. position. Okay, this is the initial position. Particle reaches here, this is the final position. There are two very important results. I want all of you to keep them in mind. So particle has rotated theta angle from here to here, A to B. Particle is moving with uniform speed. This is a uniform circular motion. So in uniform circular motion, particle is moving with constant speed equal to v. Okay, so particle is moving with constant speed which is equal to v. So particle is moving with constant speed which is equal to v. So time from A to B is equal to r theta divided by v. Time will be this. From A to B, time will be arc length divided by, see the distance, this distance will be r into theta. That is covered with constant speed v. R into theta divided by v. Distance travelled is r into theta. So distance is r into theta. Its displacement 2r sine theta divided by 2. This formula you have to remember. The formula of displacement you have to remember. Formula of displacement, distance. And what next? Change in velocity. Remember these formulas. When it travel a distance, cover an angle of theta, change in velocity is 2b sine theta divided by 2. This is the change in velocity. These all are formulas which are very, very important. So you can find the average velocity from here. You can find the average acceleration from here. Okay. Average velocity can be found out. Average displacement divided by time interval will be the average velocity. Change in velocity divided by time interval will be the average acceleration. So average acceleration you can find. This is very important case. Very, very important case. Uniform circular motion. They might directly ask the question. Particle has travelled an angle of 90 degree. What is the displacement? 2r sine 90 by 2. So it will be root 2r. So these are the direct results which you have to remember. Got it? Is this clear to everyone? Clear to everyone? Okay, so we will stop here and we start the session at, like, it's already 19:34. $15-minute break you want? 7:50 p.m. Wow, go and enjoy. Yes, 7:15 p.m. we start the class and we will complete. There are two parts are left only, no? Like one is motion with uniform acceleration, the other one is motion under gravity of the earth. Okay, let's increase the duration. 7:55 we meet, so it will be a 20-minute break. I also got tired, but please do come back. Otherwise, the most important part is about to start, motion with uniform acceleration. Don't miss this part, okay? We start the session. I want all of you to come back. Hello guys, I'm back again. So we start the new topic, and that is the motion with uniform acceleration. Means new part of this topic. Let me erase all this. Okay. So the next concept is motion with uniform acceleration. I hope you all are back. You have all liked the session. Okay. Should we start? Sir, how's Olive? Olive is good. Great. I'm not at home. I'm taking class from the office. Okay, so we start the class. Others will join meanwhile. So the concept is motion with uniform acceleration. So we have already studied the acceleration. Now we are talking about a particular type of motion, that is when acceleration is constant or uniform. So what is the meaning of uniform acceleration? What is the meaning of this? Uniform acceleration. So uniform acceleration means direction and magnitude of acceleration are constant throughout the motion. So direction and magnitude. So direction and magnitude of acceleration are constant. So direction and magnitude of acceleration are constant throughout the motion. So if acceleration, direction of acceleration and magnitude are constant throughout the motion, then such motion is called the motion with uniform acceleration. So value of acceleration is constant and its direction is also fixed. It is in only one direction. See, in rectilinear motion, only two directions are possible. So whether motion is like this, whether motion is like this, or motion is like this. So it is if it is rectilinear motion, it has only two directions. So you take one direction as positive. So all the parameters in this direction are taken as positive. Then all the parameters in this direction will be taken as negative. If you choose this direction as positive, all the parameters in this direction will be taken as negative. If you choose this direction as positive, all the parameters in this direction will be taken as negative. So if there is a particle and it is projected upward with 20 meter per second, and it has acceleration downward 10 meter per second square. So in this case, you will write velocity is equal to plus ka 20 meter per second and acceleration is equal to minus ka 10 meter per second square. Because upward direction, all the parameter in upward direction is taken as positive, all the parameters in downward direction are taken as negative. Okay, so this way we take the sign convention, and I already told you about that. Okay, one direction we take as positive, the other direction is taken as negative. So these are the basic things about before we start the motion with uniform acceleration. So before we start the motion with uniform acceleration, these are the all basic information which we need to understand. See, u, we define this as the initial velocity. Initial velocity. A, this is acceleration. It will represent the acceleration. S, displacement. X, position, and T will represent the time. Okay, these are the all symbols we will use in this motion with uniform acceleration. Got it? Everything is clear till now? So let's talk about velocity as a function of time if acceleration is constant. So acceleration is constant. We know dv by dt is equal to acceleration. So acceleration is equal to, or dv is equal to a dt. We just integrate it. At t equal to 0, the velocity is given as u. At time t, velocity is v. So when you integrate it, you get v minus ka u. And acceleration is constant. It will come out of the integration. And integration of dt will be equal to t. So you get first equation of the motion, u plus ka at. This is the first equation of the motion. And this equation is valid only if acceleration is constant. So first equation of motion is v equal to u plus ka at. What is the meaning of this? What is the meaning of this? Like, what is the meaning of this when acceleration is constant? So for example, there is a particle which is moving with 2 meters per second and the acceleration is 3 meters per second square. So every 1 second the speed will increase by 3 meters per second. So let's say this is at t equal to 0. So acceleration is 3 meters per second square, initial velocity is 2 meters per second. So at t equal to 1 second, its velocity will become 5 meters per second. At t equal to 2 seconds, its velocity will become at 8 meters per second. So every 1 second, the speed will increase by 3 meters per second. So its initial speed is 2 meters per second. So after 1 second, it will be 5 meters per second. After another second, it will be 8 meters per second. After another second, it will be 11 meters per second. After another second, 14 meters per second. So every second, the speed changes by 3 meters per second. So this is the meaning of the acceleration. And if it is constant, the change will be constant. Okay. Let's say a particle is moving with 10 meters per second and the acceleration is 2 meters per second square. They both are opposite to each other at t equal to 0. So at t equal to 1 second, the particle will be moving with 8 meters per second. At t equal to 2 seconds, it will be moving with 6 meters per second. Now the speed will be reduced by 2 meters per second. Every second the speed will reduce by 2. Okay, so it is moving with 10, it will become 8, 6, 4, 2 and 0. This way the speed of the particle will, this way the motion of the particle will be there if acceleration is constant. So speed will change like that if acceleration is constant. Is this clear to everyone? Is this clear to everyone? This was the first equation, and how does the motion is get affected, that we can understand. So the magnitude of acceleration, what is the magnitude of acceleration? By that amount the speed will either increase every second or will decrease. So let's say I drop this pen from here. What is the acceleration of this pen? That is g, downward. Value of g is 10 meters per second. What is the initial velocity when I drop it? 0. So in 1 second, it will attain 10 meters per second velocity. In the other second, it will attain 20 meters per second. In the next second, 30 meters per second. Every second, its speed will be increased by 10 meters per second. So 0, 1 second, 10 meters per second. At 2 seconds, 20 meters per second. At 3 seconds, 30 meters per second. If I project upward with 40 meters per second, if I project this pen upward with 40 meters per second, now acceleration is downward, speed is upward. So every second the speed will reduce by 10. So 40 meters per second upward velocity is given to it. After 1 second, it will be moving with 30 meters per second. After another 1 second, it will be moving with 20 meters per second. After another 1 second, it will be moving with 10 meters per second. And after 1 second, it will come to rest. Okay, got the idea? When acceleration and velocity are in the same direction, the magnitude of speed will increase by the magnitude of acceleration at every 1 second. And if they both are opposite to each other, the speed will decrease. Speed will decrease. Clear? So the first equation of motion is clear to everyone? The first equation of motion is clear to everyone. Let's talk about the second equation of motion. Second. So now when acceleration is constant, we already know v equal to u plus ka 80. This was our first equation of motion. This was our first equation of motion. But this is valid only if acceleration is constant. I can write dv can be written like v can be written like dx by dt, and this is u plus 80. Dx can be written like ut u dt plus 80 dt. Now you integrate both side. Here it will be x final minus ka x initial. It will be ut plus ka half 80 square. This is the change in position, which is called the displacement. And displacement comes out to be ut plus half 80 square. So displacement will be equal to ut plus half 80 square. So displacement is given by this formula, ut plus half 80 square. This is our second equation of motion. This is our second equation of motion. S is equal to ut plus ka half 80 square. U is the initial velocity, A is the acceleration. There is one more important concept, displacement in nth second. Displacement in nth second. So displacement in nth second is given by this formula, u plus a divided by 2 into 2n minus 1. How do we find displacement in nth second? Displacement in n second minus ka displacement in n minus 1 second will give you displacement in nth second. It will give us displacement in nth second. This is the formula of displacement in nth second. You will get displacement in nth second by using these two formulas. So there is very important concept. So we will cover all the concept of the second equation of motion in one go. If u is equal to 0, means particle start from rest. Particle start from rest. If there is a particle and it is start from the rest, u is equal to 0. So displacement in nth second will become a divided by 2, 2n minus ka 1. So displacement in first second. So put n equal to 1, it will be a by 2. So if a particle start from rest, then in first 1 second, it will travel a by 2 distance. It will travel a by 2 distance. So if I drop this from here, what is the acceleration of this? G, which is 10 meter per second. So in first second, how much distance it will travel? 5 meter. In the first second, because it is starting from rest. So I release it. In 1 second, it will travel 5 meter. Got it? Displacement in second. So put n equal to 2. It will be 3a by 2. Displacement in third second. It will be 5a by 2. So there is a ratio of 1:3:5 if particle start from the rest. Remember this. This is a very important thing. If particle start from rest with constant acceleration, and acceleration is constant, then only the distances traveled by the particle in successive seconds are in order of 1:3:5:7 and so on. So if I drop this pen from here, in 1 second, how much distance it will cover? 5 meter. In next second, 15 meter. So total distance in 2 seconds will be 20 meter. In next second, 25 meter. In next second, 35 meter. Next, 45 meter. So now you add these distances. In first second, it will travel 5. Second, 15, means 20 meter, total 20. 25, so total 45. In 3 seconds, it will travel 45 meter. In next second, it will travel 35 meter. Na? So 45 plus 35, 85. In 4 seconds, it will 80. 4 seconds, it will travel 80 meter. In 5 seconds, it will travel 125 meter, because the next second it will travel 45 meter. This is the way I find most of the questions. Like, I don't have to solve the questions every time. This way I can find the direct answer. So displacement in every second is 1 raised to 2, 3 raised to 5 and so on. If acceleration is constant, particle start from the rest. So 2 equations are complete. There is one more concept of this. We are not going to the third equation till now. No? Like, if acceleration is constant, so average velocity is given by displacement divided by time interval, and displacement is ut plus ka half at square divided by time interval. Average velocity is equal to u plus at divided by 2. So average velocity is equal to 2u plus at. So we can write u plus at divided by 2. So average velocity is equal to u plus v divided by 2. So this is the average velocity if acceleration is constant. This is only applicable if acceleration is constant. This is also very important formula. So average velocity is given by u plus ka v divided by 2 if average acceleration is constant. So v average is equal to u plus v divided by 2, and v average into time is equal to displacement. Sometimes this gives us faster result. This is okay. I hope everything is crystal clear to every student attending this. Arey yaar, I don't like this. Everything is crystal clear to everyone. Okay. So these are all the formulas about this is the second equation of motion. We haven't gone to the third equation of motion. Okay. So these are related to displacement. All the equations are related to the displacement. Oh no. There is third equation of motion. We'll have to add one more slide. So it says motion with uniform acceleration. Motion with uniform acceleration. Okay. So motion with uniform acceleration, third equation of motion. We have one more formula of the acceleration, which is a equal to v dv divided by dx. So v dv we take on one side. This is the third equation we are deriving. V dv equal to a times dx. Integrate it at x initial velocity is u, at x final velocity is v. So v square divided by 2 minus ka u square divided by 2 is equal to a into x final minus ka x initial. So v square is equal to u square plus ka 2a into displacement. V square is equal to u square plus ka 2a s. This is the third equation of motion. Third equation of motion. So if somebody gives you v equal to root over ax plus ka b, this is motion with uniform acceleration. Okay, motion with uniform acceleration. Whenever you see this kind of velocity, and you will see this kind of velocity in wave on a string. So wave on a string, there are lot of problem like this. When you say v equal to root over ax plus b kind of form is given, this velocity is also due to the uniform acceleration. So we are just doing the under root of this. So whenever acceleration is constant, this kind of velocity is also given sometimes. If this velocity is given, you have to just identify like this is a motion with uniform acceleration. This is a motion with uniform acceleration. Okay, clear? Motion under gravity of the earth. Motion under gravity of the earth. Motion under gravity of earth. Motion under gravity of earth. So acceleration due to gravity of earth, gravity of earth is equal to G. Value of G is 9.8 meter per second square, or sometimes G equal to 10 meter per second square. Okay. So if it is given as 9.8 meter per second square, then take that 9.8. Otherwise, 10 meter per second square is taken as the value of G. Okay. If upward direction is taken as positive, if upward direction is taken as positive, then first equation becomes V equal to U minus ka GT. Second equation becomes S is equal to UT minus ka half GT square. And third equation is becomes V square is equal to U square minus ka 2GH. So ultimately we replace A with minus ka G, and we get all the equations of the motion if particle is projected vertically upward. All equation of the motion if particle is projected vertically upward. So with the motion under the gravity of the earth will be given like this. Got it? Is this clear? Everything is clear to everyone? All the case with the motion with uniform acceleration are here only. Let's solve some numerical on this. Okay, let's try to solve some numerical, and there are 3 cases of the motion under the gravity that I'll explain, and we are done with rectilinear motion. A particle experiences a constant acceleration for 20 seconds after starting from the rest if it travels a distance of s1 in the first 10 seconds and a distance s2 in the next 10 seconds. Then what is the relation between s1 and s2? What is the relation between s1 and s2? Okay. So in first 10 seconds starting from rest, u is equal to 0. Particle is moving under constant acceleration. Acceleration is constant. So distance traveled in first 10 seconds, s1 is equal to ut plus half at square. Put u is equal to 0 and value of t equal to 10. So s1 will be half a into 10 square. s1 is equal to 50a. Okay, so 50a meter is the distance traveled in the first 10 seconds. Distance in first 20 seconds. In 20 seconds, what is the distance traveled? So s in 20 seconds will be equal to half u into 20 plus half a into 20 ka square. Distance in 20 seconds comes out to be u is 0. This comes out to be 200 a. So distance from 10 second to 20 second, that will be distance in 20 second minus ka distance in 10 second. It will be 200 a minus ka 50 a. It will be 150 a. So s2 is equal to 3 times s1. or you could say S1 is equal to S2 divided by 3, and this will be your answer. And this will be your answer. S1 is equal to S2 divided by 3. S1 is equal to S2 divided by 3 will be the correct answer. Similar concept you can apply, like first, second, second, second type of question concept will be there. So if you say a particle travel with constant acceleration d distance in first 5 seconds, what will be the distance traveled in next 5 seconds? It will be 3d in next 5 seconds, 5d in next 5 seconds. So in same interval, if particle start from rest with uniform acceleration, the distance traveled in any interval, like same interval, successive same interval, is in ratio 1:3:5:7. Same thing we could prove here. Okay, question number 10 is done. B option is the correct option. A body start from rest. What is the ratio of the distance traveled by the body during the 4th second and the 3rd second? This we could directly find. Distance traveled from in 4th second is u, body is starting from rest, so u is equal to 0. A divided by 2, 2n minus ka 1. 8 minus 1 is 7. So 7 A divided by 2 will be the distance traveled in the 4th second. Distance traveled in the 3rd second, A divided by 2, 2 into 3 minus ka 1. So 5A divided by 2 will be the distance traveled in the 3rd second. So distance traveled in 4th divided by distance traveled in 3rd will be equal to 7 divided by 5. And this will be your answer. Okay, so 7 divided by 5 will be the answer. A option is the correct option. Question number 11, clear? Yes, many of you were able to solve this question. This is direct formula based. Okay, so there are total 5 formulas we have. V equal to u plus at, S equal to ut plus half at square, S nth is equal to u plus a by 2, 2n minus 1. Average velocity is equal to u plus v divided by 2, and the v square is equal to u square plus ka 2s. A option is the correct option. Next question. There is one more question. A body of mass 10 kilogram is moving with a constant velocity of 10 meter per second. Body of mass 10 kilogram moving with constant velocity of 10 meter per second. When a constant force act for 4 seconds on it, it moves with a velocity of 2 meter per second in the opposite direction. The acceleration produced in it. So what is happening here? A body is going in this direction with 10 meter per second square, 10 meter per second. Now it is moving in opposite direction, so definitely acceleration is in this direction. So I don't know direction of the acceleration. The one thing I know is velocity is 2 meter per second is in this direction. Okay, at t equal to 4 second. At t equal to 0, it is in this direction. Velocity u is 10 meter per second. V is minus ka 2 meter per second. One direction I'll take positive, other will be negative automatically. Acceleration I don't know. So I'll write V equal to u plus ka at equation. You'll say, sir, write with minus. No, I don't have to write with minus. I don't know what the direction of the acceleration. I'll put these values with negative and positive sign. So what is the velocity after 4 seconds? That is minus 2. What was the initial velocity? That was 10. What is the time taken? That is 4. So 4a comes out to be minus ka 12. A comes out to be minus ka 3 meter per second square. It will give the answer with sign. A is minus 3 meter per second square. That means ke opposite to the 10 meter per second velocity. It will be opposite to 10 meter per second velocity. So acceleration is minus 3 meter per second square. So if some particle is moving with 10 meter per second, okay, acceleration is 3 backward. In first second, what will happen? The speed will reduce by 3. So it will become 7. In the next second, it will reduce by 3 again. It will become 4. In next 1 second, it will reduce by 3. It will become 1. In next 1 second, the 3 meter per second will be added in this direction. It was moving with 1 meter per second. So 1 will become 0 and 2 meter per second will be in this direction. Okay. So this way the acceleration affects the velocity. acceleration will affect the velocity like this. Question clear? Question number 12 is clear to everyone? So the B option is the correct option. Yes, it should be the correct option. Now we talk about the motion under gravity of the earth. So we talk about the motion under gravity of the earth. There are three special cases. We talk about them one by one, and I'll tell you a trick as well. That trick will save a lot of time for you. And there was a question in NEET 2023 paper that was from this part only. So there are three cases which we will cover, and that question belonged to third case. That was from the third case. It was a little bit difficult question for the students, but now after watching this, you will be able to solve that question as well. So I'm going to talk about all the three cases. So first, case 1, vertical projection. Case 1 is vertical projection. So case 1 is vertical projection. We're projecting a particle in vertically upward direction. Okay, so a particle is projected from here in upward direction. The initial speed is given as u. It has acceleration in downward direction, that is g. Initial speed is u. Particle will go upward like this. At the maximum height, it will stop, and then it will come downward. So you are able to understand it properly. I am drawing this line a little rightward so that both the motion can be clearly differentiated. When particle is at this point, so something will happen here, okay? So this is the upward motion and this is the downward motion. Particle is going upward. You just tell me few things. When it is coming downward, what is the direction of acceleration? What is the direction of acceleration when it is coming downward? What is the direction of acceleration when it is coming downward? You are taking upward direction as the positive direction. What is the direction of acceleration when particle is coming downward? See, when it is going upward, the velocity is upward, acceleration is downward. But when it is coming downward, what is the direction of acceleration? What is the direction of acceleration? What is the direction of acceleration when particle is coming downward? Will the direction of acceleration changes during the motion? Will the direction of acceleration changes during the motion? Will the direction of acceleration changes during the motion? Will the direction of acceleration changes during the motion? No. Throughout the motion, when it is going upward at the highest point and coming downward, the acceleration is downward only. So that's why I can say this motion is with uniform acceleration, because acceleration is constant throughout the motion and its direction is also same throughout the motion. So direction of acceleration will remain downward throughout the motion and the magnitude of acceleration will be g throughout the motion. So for entire motion, I can say the acceleration is equal to minus ka g, and it is constant. It does not change during the motion. Is there anything which changes during the motion? Yes, velocity. Velocity will change in magnitude as well as in direction. When it is going upward, acceleration and velocity are opposite to each other. Particle will slow down. Particle will slow down, slow down, slow down. At the highest point, the velocity becomes 0. At highest point, velocity becomes 0. Will acceleration also be equal to 0? No. Acceleration is again g but downward. So is it necessary that when velocity is 0, acceleration should be 0? No. At the highest point, velocity is 0, but acceleration is again, acceleration is there. Acceleration is non-zero. It is not necessary that they both will be 0. When v is 0, it is not necessary that A have to be 0. Okay. So at the highest point velocity is 0. This is the example of that. At highest point velocity is 0, but acceleration is not 0. Okay. Particle goes like this, and there are two terms with two things which we have to find. One is the maximum height. One is the maximum height. We have to find maximum height. One is maximum height. One is the maximum height, H max. H max we have to find. Particle is going from here to coming back here. So this is the initial position. And this is the maximum height. So when velocity of the particle becomes 0, during that interval, the displacement is called the maximum height. So displacement will be H max when velocity becomes 0. So which equation we need to apply here? Third equation of motion, which says v square is equal to u square minus ka 2g s. This equation. Here you put v equal to 0, u is u square minus ka 2 into g into h max. So h max comes out to be u square divided by 2g. This is the formula of the h max. Okay, so this is the formula of the h max. H max is equal to u square divided by 2g. So vertical component of the velocity divided by 2g. What is the time of flight? Second concept is time of flight, capital T. What is the time of flight? Time of flight is the time till the time it was in air. So from here to here, this time is called the time of flight. This whole time is called the time of flight. So it started from here, it went up and came back to this point only. So the displacement of the particle becomes 0. So that time in which displacement becomes to 0, particle started from this point and it came back, it returned back to the same point. That duration is the time of flight. For that entire time it was in the air. What we do? We say that time in which particle come back to the starting point is the time of flight. Equation of S is equal to ut plus ka half at square. So we put values here. S becomes 0. U into t minus ka half, value of a is minus g into t ka square. So t value of t, we get two values of t, 2u divided by g. This is the time which is the time of flight. So in 2u by g time it will come back to the starting point. And time taken to reach h max is t h max is equal to capital T divided by 2, which is equal to u divided by g. Okay, these are the all two formulas which can be asked on this. This motion is symmetric. When particle goes up and comes down, the time taken, the motion is symmetric. Okay, it will take equal time in going upward and coming downward. So these are two very important formulas on this part which can be asked. That's case 1 is complete. Let's move to the case 2. So case 2 is more important actually now. I find this very important. Particle is released from height. So a particle is released from a height h. Particle is there, it is released. H height. Okay. So there are two questions which can be asked. Time to reach ground is equal to root over 2h divided by g. This formula you have to remember. Velocity of a strike with ground, the speed with which it strikes the ground, root over 2 into g into h. It will strike with the ground with the speed is equal to root over 2 into g into h. Time it will take time to reach the ground, root can the 2h divided by g. So time to reach the ground is this and this. We are going to analyze this in a little bit more detail, because this is a very wonderful case. Like, so let's say ground is here and a particle is released. But this will help in solving other cases as well. Particle is released from here. Okay, at equal to 0, released from rest. What is the distance traveled by a particle with moving with uniform acceleration in 1 second? What is the distance traveled by a particle which is moving with uniform acceleration in 1 second? That is equal to a by 2. Okay, that is equal to a by 2. In first second, it will travel a distance of a by 2. This particle reaches, in first second, it will travel a distance of okay. So t equal to 0, it has started its motion with acceleration equal to g. At t equal to 1 second, what will happen? It will attain a velocity of 10 meter per second. What is the distance traveled by it? That will be 5 meter. Okay. In next 1 second, it will travel a distance of 3 times. In next 1 second, it will be moving with 20 meter per second, and the distance traveled will be next second, the distance traveled will be 15 meter. Okay, every second 5, 15. In the next 1 second, in next 1 second, it will be traveling with 30 meter per second. Next second, 40 meter per second. Every second, its speed increases by 10 meter per second. This distance will be (25 meter, 35 meter. Okay. So every second it will travel 5 meter, 15 meter, 25 meter, 35 meter. And every second its speed becomes 10 meter, 20, 30, 40 meter per second. Now we can reverse this situation. So many questions which have in those questions, if velocity is given like multiple of 10, you can directly solve. What are those questions? We are going to talk about them. So if a particle is released from 80-meter height, if a particle is released from the 80-meter height, you can directly say, okay, sir, in first second it will travel 5, then 15, so 20 test traveled, then 25, so 45 meter is total, then 35, 80 meter. So in 4 seconds it will reach the ground. So if a particle is released from the 80-meter height, it will reach the ground in the how many seconds? 4 seconds. If a particle is released from the 45-meter height, 45, this is sir 5 meter, 15 meter, 25 meter, 45 meter, 3 seconds. If I say a particle is released from 125-meter height, you'll say, sir, 5, 15, 25, 35, 80, 45, 125. Okay, in 125 meter, it will travel in the 5 seconds. Got it? Is this clear? Okay, what will be the speed at when it strikes the ground? 125 meter. Okay, sir, it is taking 5 seconds. So 10, 20, 30, 40, 50. 50 meter per second will be the speed. Can you remember all these datas? It will definitely save your time. Okay. So the reverse can also be done. What is the reverse concept of this? So I can cover 2 more questions on this part. What is the reverse concept? Like, if somebody says a particle is projected with 40 meter per second, so this concept is applicable only if the velocity is multiple of 10. Okay, so 40 meter per second is the speed given to the particle. What is the maximum height time taken? So in 1 second its speed will become 30 meter per second. In another second its speed becomes 20 meter per second. In next second 10 meter per second, and finally stops. Now it has gone upward, na? It will come downward. So downward motion I am representing like this. So you'll say in next 1 second its speed will be 10 meter per second, 20 meter per second, 30 meter per second, and here it will strike with the 40 meter per second. Can you analyze this? Can you find the height? Here it will not be 5, 10. No. You will come back. You say, okay, it is projected with 40 meter per second. Now, in 1 second it will be 30, 20, 10, 0. So it will take 4 seconds in going upward. Again it will take 4 seconds in coming downward. In the last second, when it is at the topmost point, it will cover 5 meter, 15 meter, 25 meter, 35 meter, means 80 meter. So the maximum height will be 80 meter. So this height 80 meter. 4 seconds going upward, 4 seconds coming downward, 8 seconds it will take. So somebody asks you, what is the velocity at t equal to 6 seconds? So you can either say like, sir, what 4 seconds, 5 seconds, 6 seconds, मतलब minus 20 meter per second. Or if I apply the formula, u is 4 minus ka g into 6. This formula will automatically give you minus ka 20 meter per second. Minus 20 meter per second means it is coming downward with 20 meter per second. If you say, what is the velocity at t equal to 2 seconds? So put in place of the 6, you put 2. It will be 20 meter per second. Okay. It will be 20 meter per second. It will be positive. Got it? Got it? Is this clear? Clear? Guys, we have to cross 300 likes before I end this class, okay? We have to cross 300 likes. Now, there can be a question like this. So, if somebody says a particle is projected from a tower, the height of the tower is 60 meter and the particle is projected with 20 meter per second. Okay, the particle is projected with 20 meter per second. It goes up. This time of strike we have to find. This we have to find. Okay, if somebody asks you this question, a particle is projected from the height and when it reaches the ground, so you'll say, sir, in 1 second its velocity becomes 10 meter per second. Okay, in the next second it becomes 0. I'll say yes, you are right. So 20, 10, 20, 10, 0. In 2 seconds it will be at the highest point. Now it will start descending. In 1 second it will be moving with 10 meter per second, and in another second it will be moving 20 meter per second. So in 2 seconds it will reach to the same position. So 1 second, 1 second, 1 second, 1 second. So in 4 seconds it will be at the same level. Okay, and in 4 seconds it will be at the same level and moving downward 20 meter per second. This distance I know. This distance is 5 meter. This distance is 15 meter. Now, in the next 1 second it will travel 25 meter. In the next 1 second it will travel 35 meter. 25 plus 35 is the 60 meter. Means it will strike here with what velocity? 20, 30, 40. With 40 meter per second. What will be the time taken? 4 seconds plus 2 seconds. Time of strike will be 6 seconds. Or you could find this like displacement is minus ka 60 meter. Right, minus 60 is equal to 20 into t minus ka half 10 into t ka square. You solve this equation, you will get the displacement from here as well. Okay, you can apply second equation of motion as well. Second equation of motion, you will get the same result. So in that second equation of motion, what will be the value of the displacement? Minus ka 60. I taught you in the beginning. This is the initial position, this is the final position. Displacement vector will be downward. So minus 60 is the displacement. Let's solve some numerical on this as well. So question number 13 is there. A body falls freely from the rest. It covers as much distance in the last second of its motion as covered in the first 3 seconds. So in the last second, it is covering the distance equal to distance covered in the first 3 seconds. The body has fallen for a time. This is a very wonderful question actually now. So what will be the distance in first 3 seconds? What will be the distance in first 3 seconds? You will say, sir, 5 plus 15 plus ka 25. It will be 45 meter, na? 45 meter. 45 meters is the distance traveled in the first second. Distance traveled in the last second. Last second. Let's call it nth second. Let's say last second is the nth second. Distance traveled is 45 meter. Because in whatever distance is traveled in the first 3 seconds is the distance traveled in the nth second. So u plus ka a, which is g divided by 2 into 2n minus 1 is equal to 45. Particle was released from rest. U is equal to 0. G by 2 is 5. So 2n minus 1 is 9. N is equal to 5 seconds. It will take total 5 seconds. So particle reaches ground in the 5 seconds. Particle will reach the ground in the 5 seconds. So this is the combination of all the concept of which I have taught you till now. Clear? Clear? This question is clear? Let me know if there is any confusion. Okay. A stone thrown upward with a speed u from the top of the tower reaches the ground with a velocity 3u. The height of the tower is. So what are you doing here is, there is this ground, there is a tower, you have projected a stone with a speed u. It went up and reaches the ground with 3u. Okay. What is the displacement? Displacement is equal to minus h. What is the acceleration? Which is equal to g downward. What is the initial speed? U. What is the final speed? Minus ka 3u. Which equation I must apply to find the h? So initial speed is given, final speed is given, displacement is given, acceleration is given. But the displacement we have to find, acceleration is given. So third equation of motion we will apply. Third equation of motion. So final speed is minus ka 3u ka square. It will hardly matter if you put minus 3u or plus 3u. Initial speed is u square plus ka 2 into acceleration is minus ka g. Displacement is minus ka h. So 9u square minus ka u square is equal to 2gh. h comes out to be 8u 4u square divided by g, and this will be the answer of this wonderful question. So 4u square divided by g will be the answer of this amazing problem. So 4u square divided by g will be the answer of this question. Got it? Question number 14 is done. B option is the correct option. 4u square divided by g. Third equation of motion. We have to identify what is given, what we have to find. Question number 15. A body falling from a high minaret, minaret पता नहीं क्या है, traveled 40 meter in the last 2 seconds of its fall to the ground. Height of this minar, I think they are referring na, in meter. So body started to fall from h height, from here, acceleration g, u is equal to 0. Okay. In the last 2 seconds, let's say time taken is capital T. So capital T is equal to root over 2h by g. This is the first relation. In the last 2 seconds, t minus ka 2 will be root over 2h minus g. Let's say in t second, body is reaching here. It is covering capital H distance. I'm saying in t minus ka 2 second, body is covering this distance h. So t minus 2 will be this, capital T will be this. This distance is 40. The last 2 second distance is given as 40. So capital H minus small h is 40. We get capital H from here. Capital H will be gt square divided by 2 minus ka g, t minus ka 2 ka square divided by 2 is equal to 40. Okay. We solve this equation. T square minus ka t square minus ka 4 plus ka 40 is equal to 8. So g by 2 is 5. G by 2 is 5. So we divided this with 5. Here it will be this. T square will cancel out. 40 equal to 12. T equal to 3 seconds. 3 seconds. So height h is equal to gt square divided by 2, which comes out to be 45 meter. So in first 1 second it travel 5 meter, then 15, and then 25. So 15 or 25 is 40. In last 2 seconds it is traveling 40 meter. Now we could have directly find out this, like without solving, because once after 3 seconds it will cover 5, 15, 25, 35 meter. So in last second 60 meter. Okay. So this is the way we can solve the question. Okay. If something different is given. There are such few questions on the like graph related problems. I think it is heating. Let me export a PDF. It might shut down. We might lose the recording or the like PPT. Actually AC is not working here, so there is a it got heated actually now. So we'll end the class very soon. Few questions are remaining. So what is this question? The graph of displacement versus time is given. Displacement versus time is given, and velocity time graph we have to find. So slope of displacement versus time graph gives us the velocity. So here slope is positive, velocity will be maximum. Here slope is decreasing, and here slope is 0. So velocity is maximum, then it decreases to 0, and then it becomes negative. So in starting, velocity is positive and maximum, it continuously decreases, become 0, and then become negative. So here they are saying velocity is negative. No. Here they are saying velocity is 0 and then increasing. No. Velocity is positive, then decreasing, become 0, and then negative. No. What will be the answer? Initially velocity is positive, decreasing, become 0, and then negative. A option will be the correct option. So slope of displacement versus time curve gives us the velocity. A option will be the correct option. Next question, question number 17. A particle starts from the rest. Its acceleration versus time graph is as shown. The maximum speed of the particle. V final minus का V initial is equal to area under acceleration versus time. This I have already taught you. If acceleration versus time curve is given, the area of the acceleration versus time curve gives us the change in velocity. Particle started from rest, so initial velocity is 0. So final velocity, the velocity at any time will be equal to area under the curve. Area under A versus T. So when the velocity will be maximum, when you cover the entire area, means when area is maximum. So area is maximum till 11 seconds. This entire area will be equal to velocity. So maximum velocity will be equal to half, base is the 11, height is the 10. So 55 meter per second will be the maximum velocity at 11 seconds. After that acceleration is 0, it will continue moving with this velocity. If you say like, sir, here, what will be the velocity? So only this area you will cover, this. Here, what will be the velocity? You will add this area as well. When velocity is maximum? When you can cover the entire area. So maximum velocity they are asking. The entire area will be the maximum velocity. Whatever I taught you. A ball is thrown vertically upward. Which of the following graph represent the velocity time curve for the motion during the flight? So when you throw a ball upward, the acceleration is downward. Velocity is equal to u minus ka gt. So velocity time curve will be a straight line. Relation between both is this, and the slope will be negative. So when particle goes up, its velocity is positive, but finally it becomes 0. And now the velocity becomes negative. It will be coming downward. Velocity time curve will be, this y-intercept will be positive, slope will be negative. So velocity time curve will be like this. D option will be the correct option. This is velocity versus time. If they ask speed versus time, this is a speed versus time. Speed can never be negative enough. So negative part will come on. So when particle is going downward, its speed is increasing. So speed is increasing. See, this is speed versus time, this is velocity versus time. But they have asked velocity versus time curve. So this will be the answer. D option is the correct option. Guys, rectilinear motion I have taught you completely, and there is a new year resolution, and which is valid up to 4th. No, it is already gone. There is a Lakshya MBBS batch for NEET UG 2024. If anyone wants to join this batch, use the referral code Kailash10 and you can join this batch. One more early enthus batch is there for 2025. Same referral code, early bird offer chal raha hai yahan pe. You can avail this course at 23,624 and you can start preparing for NEET 2025. You can early start your preparation, and referral code is, my referral code is Kailash10. Use this referral code. There is the Unacademy scholarship test is also there at just 99 rupees. You can enroll for this. Thank you guys. I hope you all like the session. Don't forget to comment. Whatever was your, whatever is your feedback about the session, do comment after the class is over. Not in the chat box, after the class is over. Those who have covered till end, also talk about it. Also mention this, okay, sir, I have completely watched the session. It was helpful or not? Were you able to solve the questions or not after attending this session? Everything you have to just mention in the chat, mention in the comment, okay? And please guys, don't forget to like this session, share this session among your groups. If you have any group, do share this session so that others can also get benefited. Like I get a reach, more students are able to join my sessions. And next session will be on the projectile motion. After that, we will cover the relative motion. So class 11th portion I'll be teaching you on this YouTube channel. So continue following my sessions, and don't forget to subscribe the YouTube channel, this YouTube channel, where you are getting the you are getting the dedicated lecture of the top educators of the Unacademy. And I have ongoing batches on the Unacademy as well. One is a NEET Endgame crash course for NEET 2024, where I'm teaching class 11th portion. There we solve the numericals as well, like we cover. I'm going to revise the class 11th portion. So if any one of you wants to join that batch, the same referral code will help you in getting the maximum discount. And this is my referral code, KAILASH10. Use this referral code and go and enroll for the NEET Endgame crash course for NEET 2024, which is started early. You start early, you finish early, and you enjoy early. Okay, guys. So I'm going to end the session. I hope you liked it, and you have liked it. Okay. Bye. Take care. So see you all in the next session on the projectile motion. Okay. Bye. Take care.